Okay, I'm recording, so let's freaking go. So, okay, quick recap for the context for the recording. We had our fun with Warren's abstract machine, and we decided to move to a more commercial VM called the Beam because two reasons. First, there's not really a candidate for logic programming in the Beam. There are some toy programming languages out there, but they don't do much. So we want to make one. And the second reason is because using the Beam allows Magetta to use Mnesia, which means that we don't have to spend 45 years to try to keep up with Postgres in terms of functionality to have a database. So that's great.
And that unlocked me to go with a even more smart idea that I forgot to introduce in the beginning, but I'll save time for now.
Wait, you have any? No, you can say the idea right now. Is that a like a?
Uh, so there's this thing called the semantic data model, right?
I had never heard of it.
Uh, so it's basically think of the relational model with a different development than the one that took with CJ Date. So it's actually appeared around the same time with the same goals, but then when you embed the semantic relational data model, it's a different way to use relations to express the relational model. So that is very interesting.
Okay, never
I
heard
should
of it.
probably go over that. Yeah, I'm having classes with a professor, uh, and he's basically teaching me that right now. So I'll
Great.
introduce that later when the time comes.
It's down there, Marim. It's down there. Dev
Mageta,
shells.
out of
Yeah.
curiosity, do you have any recommended reading on that topic? Because that sounds interesting.
I have a Wikipedia page and some obscure articles from a
Leg
professor called David McGovern. Do you want to
I
legacy
read?
really like
packages.
I really like obscure articles, Mageta.
Yeah, we know.
I I will get them for you then.
Legacy packages dot Erlang.
Let me
I
just
guess
send the wiki page, sort of one. There we go.
And then do the Nix develop. We should be able to see the things. Yeah, but does this new model of treating relations is this matters for the implementation, I guess, right, Magetta?
Wait, sorry, what?
This semantic data model that you're talking about. This matters for the implementation of the database, or
Uh, it matters for me to change the approach. The idea is this: if you read CJ Date, right?
yeah,
So he talks all the time about relvars, right? For
yeah,
example,
yeah, yeah. But that's not the
relvars
same
in
thing as.
yeah, but just to give one example that I think is easier,
Uh-huh.
relvars. There's this debate. CJ Date's more like a Platonist guy. The others are more into nominalism, I would say. I think that's a fair take on them. Um, and the approach is distinct because they try to ignore completely the idea of having a relational variable. You see, because that's a procedural way to look at something that is purely declarative. So anyway, there's more debates on that also,
Sure, sure,
but
sure.
uh, so the idea is like we'll substantially changing the implementation, but not that much in the under the interface, right? For the presentation to the user, it will still more or less be the same, but I think it's substantially easier to do it this way. You just need to understand some basic concepts, right? And everything is much better.
Yeah, okay. We're gonna have to have a class on that later. I never heard of it.
I can make it
how
probably a talk.
We should, yeah, you should. I think you're probably asking yourself where the fuck we're gonna put this, right?
yes.
Uh, I think we should have a folder called Beam, but outside of the lib. So it's like not included in the OCaml because we will have a Beam module in the OCaml program later because we're gonna probably make functions that will
Hmm.
help us make the thingies for the symbolic bytecode. So we should not put it in the lib folder. We should make a separate folder called Beam. Yes, just called the Beam.
What if I call it runtime?
That's a little bit misleading because some part of the runtime will be in OCaml.
Not really, no.
What part of it will not won't be in OCaml?
OCaml is the language of the compiler. Any support code that is necessary at runtime should be in the runtime, no? And that's going to be written in. Well, we decided on Erlang. In principle, could be any Bean language,
It could be
but
symbolic bytecode. I'm not
it could
suggesting,
be
but it could.
symbolic bytecode. But that's not what this directory is for. This directory is strictly for the runtime library that we're going to use,
Yeah,
right?
you didn't get it. I'm joking that you could write the runtime library for the Beam in Beam symbolic bytecode. You could.
We could,
We're
yes.
not doing that because we're not that insane. Uh, so, okay, you can call it runtime. I just think it's misleading because then the question is, okay, there's no runtime in OCaml?
1 second.
Sure. Okay, so the paper is logic for serious database focus.
It's actually the chapter, a draft chapter. You just search for that and then you'll find on Google, right? It's pretty everywhere essentially.
Semantic.
Okay, I'm back.
But it's a draft. It's not finished, right? And the other is from Pascal. It's the Nobody Understands Relational Model. So it's a pretty good article to introduce the
Uh,
difference essentially.
okay, anyway, you can make the directory runtime, Marinho, just because I think that implies there's no runtime in the OCaml program. And I think there will be. But okay.
What do you think will be there?
Well, my understanding, you can correct if I'm wrong, is that we're gonna do the code generation that will assume the existence of a runtime.
Yes.
Um, and well, I guess yeah. So isn't the code generation runtime of the compiler?
It's the runtime of the compiler. It's not the runtime of the program that we are compiling.
Okay, fair enough, I guess. It's because I'm kind of biased on our perspective, the developer's perspective. But okay.
Okay, runtime. Um,
So I was thinking on a single module called Karuta.Earl. But I don't know if that makes sense. Maybe we should split in multiple modules.
we're gonna need all of the Erlang build system, like rebar tree stuff, won't we?
Really? I thought you would
Mm,
just pick the Earl C compiler and compile the Karuta.Earl. And that's it.
I suppose technically we don't need it if we just do a single module, which is our idea, right?
Wait, we can't compile multiple modules in a single shot? Really?
I mean, we could, but then we'd have to do by hand what rebar does for us.
I was kind of not trying to go with rebar because I think it would be a little bit overkill just for a library for the runtime. But if you think that's a good idea, I guess that's okay.
Let's start without it, and if we need it, then we can add it later.
By the way, Marinho, do you have LSP on Kakun?
I
Yes.
have, but I don't have Erlang's LSP installed,
Yeah.
See if
unfortunately.
this is on the
It isn't.
Geeks platform.
It
Uh,
isn't.
No, 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 no.
I
But
mean
he's
the
Uh,
talking
the other
about
one.
the yeah the older one.
There's this here, which is a new LSP that works very good, very well. I mean, Erlang Language Platform or ELP. Search for any of those.
yeah, no, they aren't here. I checked, like when we saw that was it Zero or was it Lithium? The compilation was breaking because of the old LSP was deprecated, right? And that was in the flake. Uh,
Yes, the old LSP. I remember.
yeah, it was Lithium, not Zero. And because of that, I was like, oh, okay, let's check if this is on Geeks. And I checked then, and it wasn't.
Oh, that is
Let's
sad.
see.
Oh, you do have
Uh,
Nix, right? So you can
yeah, yeah.
package that later.
I
Yeah, sure.
can.
Uh,
The thing that hurts me is that it doesn't have formatting on the LSP.
yeah, we actually don't have a formatter for any of our Erlang programs.
What do you
Uh,
mean?
yeah, we don't, right? We don't have formatting, do we?
I mean, there is a formatter, but it's not embedded on the LSP, right?
No, but do we use a formatter ever?
On Lyceum, we were, I think.
Really?
We have one, I think.
I have no recollection of that at all.
Rebar config, right? Plugins, rebar to Nix, relax.
Or maybe it's not there, right? I think we were probably using the LSP embedded.
Oh, the Erlang compiler can actually accept multiple files. So if you have
Oh,
Okay.
multiple modules, you can just yeah. I think rebar 3 only makes sense if you actually need dependencies. If you don't, and you don't want to like be too fancy about it, you can just use a compiler. Like this is the most Zosing take I ever spoke in my life. The amount of hate
just use
that
the
he has for these
compiler.
things. Yes,
To be honest, it's not unjustified.
it's
Most of
not.
the
But he also says that everybody should just have a .so or a .a in every repo. Like,
well, that is a bit too much.
like
For
because
I
what exactly?
because he understands that we use these the build project managed systems because we don't want to handle the dependencies like that. But for him, it doesn't matter because you can just have a .so in a third party folder in your repo.
that
So you you don't
that's
need.
so you would need to compile to the operating system that the person uses
Yeah,
and distribute it. So, for
yeah.
example, I'm using Mac OS. I
I
need to
think the way
yeah.
Zig folks handled this before the package system was saner. What they did was, okay, we don't have a package system yet, so let's use Git submodules to include our dependencies, like refer to the original repository of the dependency that we care about, and then we have access to the source code, and then we can compile to whatever target we want. Because
You know
Zig
what
is good at cross-compiling, right?
you know what I think is the best today?
What?
Cabal.
Cobol?
That sounds like a joke, right? Because the thing
Haskell,
just
Cabal.
Oh, Cabal
yeah,
from Haskell.
Cabal,
Really?
yeah, from Haskell. Because if you pair that with Nix, you solve the problems from Cabal through Nix, and the thing just works, right?
No, 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 no.
The
But then okay, but that's a little bit misleading because you are driving Cabal using Nix, so you're actually doing Nix
yes,
instead of Cabal.
yes,
And the
exactly.
second thing is that this also doesn't solve the problem of having to learn Nix because Zosing also
Which is indeed
thinks
a bad language.
no, no, no. It's not only about the language. It's about
The concept
having
too, right? I get it.
an heterogeneous stack.
Yeah, but dependency is a problem. Like, there's nothing you can do to just get rid of it.
No, yes, I agree with you on that. But essentially, yeah. Let's close this tangent. We
By
all
the way,
deserve.
those yeah, yeah. Anyway, by the way, those doc at doc apparently they got deprecated on their like edoc.
No, I didn't know that.
They're telling us to use uh markdown now on the function comments.
Okay. Okay, so let's freaking go. So logic variables. What do you have in mind, Manny? Like, first of all, you need to
Uh,
export some stuff, right? So put an exports directive. Is that how is that called?
shouldn't we define things before exporting them?
Well, I think we're gonna make functions, but sure.
Oops.
It's very peaceful to look at Marinho um Kakun.
Yeah, but he's having a Vim thing.
What do you mean?
That looks
Yeah,
like Vim, yes.
yeah, he did the column W.
Well, that's because that's how you save a file.
Oh, okay.
So Kakun is close to Vim in like macros, is that it?
It was inspired by Vim,
Operations.
but it does a few things different.
Okay. Okay, so
Is Kakun
go
written in C? Just question.
C++
probably.
actually,
C++. Interesting.
and it's in the public domain.
Erlang is written in C.
Well, the
Well,
original author likes C++ for some reason, so
Okay, so let's go. What do you have in mind? Logic variables or backtracking first?
I think backtracking makes, well, it makes some sense if you don't have logic variables, but it's going to interact with logic variables in a kind of straightforward but kind of non-trivial way. So we should do variables first, I
Okay.
think.
So what do you have in
I
mind
think
to
that's
implement?
the.
Go,
I think
Margaret.
you can leave without backtracking, right? But logic variables you will need either way. So I think it's
Yeah, yeah,
better to test the idea with that first.
that's very true. We only need backtracking for multiple for
No
search
determinism,
for
essentially.
search.
Actually, we need backtracking for pattern matching as well, Mageta.
Really?
Let's
Yes.
see. You need to validate the. Well, only if you
No,
branch,
no.
no?
Only if you search. Only if you need to search.
Well, you can do a deterministic search if you're just doing simple pattern matching. That's the
Yes,
point.
that's my point. I agree.
Okay, so variables
That
first. How do you imagine we doing them, Marin?
okay, so we need a function that instantiates a new variable, and this is going to spawn. Well, this was my original idea. I'm not sure if this is the best way to do it, but
Right now that doesn't matter.
we need to spawn. Um, we need to spawn.
I think it's self because this is the module, right? We need to pass first the module of the function. So spawn Erlang.
Self doesn't return the module though. It returns the PID that's currently running the code.
Oh, it's a variable, isn't it, for the module? Dollar module or whatever.
Yeah, it's a reader thingy.
Yeah.
Uh,
So do we have that somewhere?
and the color is funny.
The color is funny. Okay, so it's the module, then the name of the function, and then the arguments.
Uh, I'm not sure if this is the way to do it though.
Just go on. I will check on Lyceum.
Thank you. The name of the function is going to be. Um, the function needs to be exported as well, no?
Yeah, all of these functions that OCaml needs to assume it exists, we need to export.
Right. Um, let's call it variable behavior, I guess. There are no arguments. Actually, there needs to be. Yeah, no, there needs to be one argument. Let's call it unbound. And then variable behavior takes an argument, which is
I see. So you guys
it.
will make directives and then summon those directives from within OCaml, right?
Yeah. Well,
I understand
just a
now.
minor inner step. We're gonna write this, make a dot beam on it, and when we
Uh-huh.
are running, we will actually like put that on the list of
Ah, I
files
see.
to,
So we
to
will
the
generate. I see. So you would just like slap these function calls on the code when you
yes,
are
yes,
emitting. Okay,
yes,
that's pretty smart.
yes. Well, it's not my idea. It was Marin's. Of course, it's smart.
Almost as if we have
No,
an
we know
idea
what
of
to
what
do.
we're doing.
uh,
Let's go.
so we need to do a receive because that's how we interact with processes. And then here's the tricky part. If we need to define a protocol for this. So if we get uh, okay, if we get a read and PID, then we send to the PID. Actually, that depends on the state, no? Um, okay, because this is not a concurrent prologue, which is a separate discussion we need to have at some point, but it isn't right now. So if we read and the state is unbound, we should just return a failure, right?
If you read, What was the question? Could you repeat? I'm still looking for the module thing.
Like if we try to read an unbound variable, because
Mhm.
this is not a concurrent language yet, maybe.
That's very
Um,
future. That's like July 2026. We discussed that.
yeah, because we don't have concurrency, that means we should fail because we're trying to read an unbound variable, right?
Yep.
Um,
Is concurrency any hard now?
Well, that sucks.
it is because concurrency interacts with in non-trivial ways with backtracking.
Yeah. Like there is a
So the
fundamental thing
problem is
about being
only
in
when you're
sequence.
sharing. Yeah. So the ultimate problem is only when you are sharing the
The variable.
uh, the variables, right? That you
Yeah.
need to assign to unify something.
Yeah. If you're using the same variable, you like if the variables interact, you need to do them in sequence. But if they are completely like separate, then maybe you
No,
can do them in parallel.
why?
No, 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 no. The problem is the following. What if I bind a variable in one thread inside of a branch,
Hmm.
while another thread has a reference to the same variable, and then the original thread decides to backtrack on that binding? That's the problem.
Yeah. So one thread changes, tries to retreat on something that is tries to retreat on a goal on something that is shared, right?
Yeah.
Essentially, that's the.
Yes,
Yeah.
that's the difficulty. It's also that's actually part of why Oz is not transactional.
Can
That's
you
something that
share? But okay, we are in the bean. Can't we share? Here's okay. I'm thinking, but since we are in the bean, can't we just share the content because it's all immutable in the end? So you're sharing the reference of that
oh
variable, but still you will need to duplicate all the. Well, you will need to fork the state of the machine at some point, right?
yeah
You need to copy the entire. Yeah, that might be.
Yeah,
yeah
that's why
that's
I
kind of
said you need to do in sequence because either you duplicate or you need to wait for the other guy because you don't know if you need to backtrack or not.
I mean, we can surely coordinate the locks, right? If you send a message and then you say, okay, I'm
um,
backtracking now.
but then that means we have to implement distributed locking, Mageta,
Yeah,
effectively.
Which honestly, in this case, sounds more insane than I think it would be.
yeah. I think we should not get ahead of ourselves. It's just not the
I agree,
concurrence.
but I'm just imagining, right? I'm dreaming
Yeah, no, I love when you're dreaming, Mageta. You're very, very, very nice to be around when you're dreaming.
when I'm dreaming.
Um, okay, here's the problem. If we try to bind, then we'll have to implement our own unification, won't we?
Yeah, probably. Okay, so according to AI, it is a question mark module in caps, not dollar.
Question
Oh,
mark.
Yeah.
Okay.
that is really ugly.
Yeah, but I'm surprised how hard it is to find this info. In
Is it
Lyceum,
really? I don't remember that, to
no,
be
there is
honest.
a macro, something that behaves like a macro that actually
Yeah,
gives
yeah,
you
something
the name
that
of
gives you the name of the module, right?
your own module.
But is that really question mark? Oh, it is. That looks ugly as heck, man.
Oh, did you find it in a trustworthy source, like a book?
No, I mean,
Okay.
I got examples of code, right, which I don't think are.
Yeah. Yeah, we're gonna have to do unification ourselves, Manin. That's also true.
Google AI says the
Actually,
same, to be honest.
and
Yeah, so let me just see if I understand. In the first receive, we are trying to read, and we are immediately failing. How do you know this is an unbound variable?
yeah, actually, I need to do a case here. Oh man, I have to do a case in a bunch of places. That's kind of
Can't you
sad.
access the module info? You can, right? Just on
Uh,
the macro again. I think you can use the module info to get the atom of the
yeah,
module.
but that module info is a generated function. I don't think we can call that in here.
Why
Case
not?
state of.
Okay, wait. What are you gonna be doing case on, Marin?
On the state, because otherwise we will have to do a bunch of cases inside of the receives, and I'd rather just do two receives instead.
What is the values of potentially of the state? Oh, unbound. I see.
Yeah,
Because
that's one of
I
them.
think we could use the maybe thingy, right? The one that Vinicius shared. Like they essentially implemented the notation for maybes. Isn't that? Does that help you?
Not really, because this is kind of tricky, right? If we do a read and it's unbound, that fails. If we do a bind of a value and it's unbound, then we tail call, right?
What are we gonna be? Oh, because this means that it's a reference. Yeah, we're calling to bind it, so then we just bound. Okay. We need to pattern match from the bound case now.
Yeah, we do. Uh, Bound value receive if we are bound and we get a read, then PID we send an OK and the value.
Oh, it is. I found a trustworthy source. It is question mark module. This
If
was
we
hard to
receive a
find.
bind,
There's
then
also a function name and function arity with the same thing, by the way.
Yeah. Go on, Marin.
it kind of sucks that we can't just use native unification because we need to treat PIDs especially.
Yeah, we need. We need to do that. We should explain to Magetta why. Magetta, do you understand what Marinho just said?
I was not paying fully attention now, so
Okay,
I don't
so
know.
the discussion is, how do we know? You see line 12 and line 8 in the code.
12 and 8.
How do you
So
know that the
receive a
PIDs are
PID.
there? PIDs there are actually valid PIDs. Like valid in the
Oh,
sense of being PIDs from processes of logic variables. So that was the question that Marinho
Uh,
brought to me. Because, for example, it may be another other process is trying to do bullshit, right? So how do we differentiate PIDs if they are external PIDs or if they are PIDs of logic variables? Because we are implementing logic variables as processes. And the solution that I proposed was just
okay. I think I understand the.
just make a place where you save like a set of PIDs, and when a
Mhm.
PID tries to do something, you do a lookup and see if the PID is present in a set or in
Yeah,
miniver
I
or
see.
whatever.
that means you should probably actually receive
A set here.
an environment
Yeah,
as
environment.
well.
I have a question. Line 13 is a little weird because this is, Erlang is not a logic language. So what is unified doing in there?
I'm going to implement that.
No, but yes, but what is going to be the output of that?
It won't output anything. It's just going to do the unification, like walk the two values to see if the structure match,
Mm-hmm.
if they are structurally equivalent.
Yes,
And it
true.
needs to
Basically,
send messages to
Ah,
handle.
that's why there's no return. We're gonna do that via
yeah. So
messages.
it's effectful, right? Essentially,
Yeah,
the idea.
yeah.
But that means actually, okay, so
And another
and
question. Don't we need to recurse on the read operations, or am I dreaming?
we do actually.
Okay.
Variable behavior, state.
Same thing on line 12.
Yeah, same thing here. Oops.
Actually, we could just put this after the case on state, no? Because everybody's doing it.
We can't because bind changes the state
Ah.
potentially.
Well, but in that case, we can just return the state and do the recur after the state anyway. After the case, I mean.
So here's an idea for locking, and see if it makes sense. If you pick a maybe that's out of the concern for now, but probably is. Um, but this is something I did yesterday, and I'm quite proud of that. Let me find here. So I was doing the volcano thing, right? The volcano iterator model with processes as well, because I quickly realized that it makes no sense to just have iterators in Erlang if you just manage the state on a recursive call, right?
Uh-huh.
Uh, so what I did is on the select. So I'm talking about the relational algebra select, right? So it's more like a filter. I needed to lock the process that is calling me first.
Mm-hmm.
So it basically calls next color, and then I lock, and then I add another receive inside that block that basically keeps looping over the state if it's done or not, right? Over if it still has any more tuples, and then it does its thing, and then when it ends, it actually on the case where I actually need to escape the call, I summon another process that keeps handling that by itself. That's a way to handle locking on our side as well, if we want to lock the copies, right?
Ah,
Because then
for
we
the
can
concurrency problem. I see.
exactly. Hmm. Okay, this is at least promising. I can see a way to solve a couple things that are around.
Awesome. Um, I'm confused. We are sending to the environment. Oh, the environment is going to be a separate process. Okay, that makes sense.
There's one problem, Lemus, that actually is the main reason why I'm not entirely sure about this approach is that technically processes are isolated, right?
Mm-hmm.
That means they can't actually share structural data, like data structures between them.
You can send, but that's
Yeah.
it.
I don't know. You can send, but that implies a copy, is what I'm trying to
Yes.
say.
Oh well, unless Erlang does structural sharing, which I don't think it does.
No, like by default, if you just run it normally, it actually has a separate heap for each process. So there is indeed
Mhm.
copying between processes when you send messages.
That's
I
no
think
problem.
there's I
Interesting.
think there's a non-standard garbage collector you can use where the processes actually can share memory, but I'm not entirely sure how to use that. And I'm not sure if it's a good idea to use that.
Okay, let's
Well, you
assume
you
we
can
won't.
use you know that structure that I said, the debts.
Mm-hmm.
You could
Yeah,
use that. That can be shared.
that's
There's sets and bags right on that thing.
Yeah, we're essentially
That's
looking for a global variable.
look for debts and ets, right? Debts is the durable, and ets is the non-durable one.
that still doesn't quite solve the problem because you still need to, if you use the durable one, you still need to like copy from the disk, right? Because it's
Yeah, you need to
durable.
write, so
Yeah,
there's another
people are
overhead.
in the Stack Overflow. People are using ETS instead of that.
Yeah, here ETS is the non-durable one. So this I'm reading here concurrency. This module provides some limited support for concurrent access. All updates to single objects are guaranteed to be atomic and isolated. This means that an updating operation, an update operation to a single object either succeeds or fails completely without any effect. Atomicity?
I found another brother. Persistent term. This module is similar to ETS.
That's crazy.
That doesn't,
Uh, and
well,
and then no intermediate. Well, we don't need the thing to persist like in the
Yeah, we don't.
disk to be durable. We just need it to be shared in an
Yeah,
atomic way.
exactly. Only
And
shared
the
is enough.
ETS apparently does that.
Because
mm,
we need
Go
to, yeah,
down
we
to
need
the
we need them to
concurrency.
be interacting on the same shit for the unification, right?
Yeah, scroll down a little bit, Mario, on this page. Yeah, there. Some functions.
Built-in term storage.
Huh. Can be seen as serializable, as if all isolated operations are carried out serially.
Tables are divided into four types: sets, ordered set, bag, and duplicated bag. What the fuck is a bag?
It's a
Uh,
multiset.
yeah.
Okay.
It's another term for a multiset. Same semantics. It's like a set, so there's no ordering, but it allows duplicates, and you can get the count of the
I
thing.
said that term completely loosely on the last string, and then Marinho was promptly with data structure knowledge.
Yeah. Okay, so are you happier, Maninho? Why not?
Even though the access of a single object, blah blah blah, traverses through a table to find the next key. Key. Okay, this is associative then. New table, ordered set, named table.
Yeah, there's more examples
Mhm.
on the bottom there.
Summary, blah blah blah.
We could use CRDTs as well, but that includes copying, I guess.
The problem is that fundamentally, unless you use a non-standard garbage collector, like you just can't share memory between processes. You have to like either do copying or put it somewhere durable, which also implies copying because you have to like write to disk and then read from disk. That creates a fresh copy.
Wait, I'm confused. Isn't ETS storage shared storage with no persistency?
That
Or am I
is an
understanding wrong?
in-memory storage, from what I understood, yes.
Yeah, but is it shared?
That's the point, yes.
Well, but Marinho just
It's the
said that
no,
it
no,
was
no,
backbone
no,
of
no,
multi-page.
Amnesia.
no, no. I'm not talking about the share, the data being accessible from multiple places. That's trivially true because a process can always send a message. I'm talking about like structural sharing, avoiding copies. Because if I try to bind a variable to a list that has a million items, I need to copy a million items if I represent a variable as a process.
Well,
Yeah,
but
but
I yeah, but
but
I thought
if
that. Go on, mate.
yeah, but even if it's in another data structure, you will need to read from the structure the million objects regardless, no? Even if you don't have to, well, reading you can say that it's probably less worse than just copying everything to the structure.
Yeah, but I have
But I
another
don't think
question.
it will copy the structure.
Exactly, that's what I thought. I thought ETS was trying to solve exactly this type of problem of like we don't have to copy the entire shiz.
That's we would have to put everything in there then to make that work.
Yeah, ETS would
Which
work as this as
is
the previous store module, right?
It would be our memory effectively.
Yeah, it would be the memory of the well of the mental model of the Warren's abstract machine. We would use this instead. Which I was expecting something like that because we need some place that we
here.
save stuff.
Performance and optimization. Choose the appropriate ETS table type, blah, blah, use efficient data structure, blah, blah, blah. So ETS apparently minimizes unnecessary data copying and serialization. That is one of the key parts of it.
Okay, so isn't that exactly what we want?
Mm,
In the
that's
current implementation, every object, some implementation details. In the current implementation, every object insert and lookup operations
Results
results
in a
in a
copy of the
copy
object.
of the object, which is a given, right? You're gonna need to do that in the first time anyway. Uh,
Well, but the lookup operation producing a copy is kind of sucks, no?
yeah, the lookup having to
No,
need
no,
a
but this
copy
means that we
is a
were
bit
wrong, Magenta.
silly.
Marinho was right. We even ETS needs to copy shit.
well, if it looks mutable, that means it must be implemented as a process, which means it does not share memory.
Okay, so it just kind of like mimics the behavior of being mutable, but it's
Like,
not.
man, this is weird because I just read the opposite on another official page. Like, what the heck?
No, 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 no. maybe they do copy in a more efficient way. They're just a dumb, naive thing.
How would they do that?
I don't know. I could imagine like copying the
Copy.
pointers or whatever. This is written in C.
Here, let's see. Tries to match the object. Notation. Successful. The reason.
Okay, so Marinho, your concern is that this will not perform great.
Yes, if we start making big data structures and we start. Actually, that's only the case if we actually need to read the data, though.
And how
Or
they
if we try
have a
to.
match. Okay, hear me out here. Sounds so silly. They have a thing called match, which you send a table, right, between quotes, and a pattern, and then look at what they say. The reason for providing a function to scan large portions of table is that searching for a particular object without having to copy the entire table from a table space to user space.
Yeah,
So
that kind of contradicts what we just read
yes,
before.
like that's completely the opposite of what they said.
Okay, anyway, Marinho, I think for the sake of having a proof of concept and just first
Let's
trying to
just
get them
yeah,
going,
let's just keep this for now. And if it's a problem later, we can re-implement it in a different way, I
no, let's
guess.
just use ETS. No, we need something to use to do the unify, right? We need something that stores that every single variable behavior process
I mean, is there
talks
a
to.
way to escape the copying in this case? I don't think so. Unless you're just chaining all the functions with one another without
Like the
sending messages.
only the only way to do that, um, I think, is either we run this like without using processes at all, which means we actually have to implement the state and the variables in a monadic style because we don't have
Yeah.
state.
Uh huh.
Um,
Uh huh. That makes sense.
or we keep the variables as PIDs, but then we need to change the garbage collector. There must be a way to configure that, when you run the beam, I imagine.
Uh, that's being a
Wait,
little
the
bit too
PI,
hopeful.
yeah, but the PID approach requires changing the garbage collection. Why? Oh, because you are speculating it's gonna be a lot of copies, right?
Well, every message sent is a copy, effectively.
The problem with the first approach is that means rewriting the entire shiz like we did in OCaml, but in here, right?
Uh, it would imply that we would, well,
We'd have to mimic the memory, we would have to go through it.
no, not really. We would need to implement the. Hmm. Actually, we need to significantly re-architect how we do this because that would mean that um, we can't just rely on just calling a library to use the specific operations that we need for Karuta. We would need to have a slightly. We would have to assume like a calling convention where we like anytime we need to do a bind, that would be a tail call. Every time we need to do a backtracking, that would also need to be a tail call in the compiled code, which is sounds troublesome to be honest.
Okay, I don't know if I completely got what you described, but I think doing the monadic approach is going to be pretty similar to what we did in OCaml for the evaluator, and I don't want to do that. Let's do the following. Let's do with the PID first, see how that behaves, and then later we care about the garbage collection. Line 11 is wrong, by the way.
Line 11.
Yeah.
Oh
Why?
yeah.
Oh yeah, it
The
is actually. I need to say
Okay.
bound
Yeah, bound, sorry.
state.
Also, do you really need the semicolon
Actually,
there?
Semicolon on this line.
I
Yeah, I don't think you should have it there, right?
yeah, I don't.
Yeah.
This is the last of this receive.
Okay. Okay, so let's assume that the PID's approach will be fine because I think the first approach will be worse. We don't even know how bad it will perform. Let's just trust that they do the copies efficiently and they figured the shit out years ago. Okay, so what's the next step? We already have the variable
You can always
behavior.
just have a limited run.
What about the unify function?
This also needs to receive the environment, actually.
And okay, but another question. Why can't we just use ETS if Mageta was reading in some places that it doesn't do the copying? Can't we just try that as well?
I don't see a way that it does without
Well,
copying,
we
to
will
be
still need
fair.
to do a copy when we send data to and from ETS regardless.
Yeah, that is true.
Okay, that's fair. I'm gonna search for the garbage collection. You can keep going there, Maria. Erlang.
Hmm. Right, and then we need to implement unify. And we should export fresh one. We probably need to export variable behavior, otherwise we can't spawn it. Actually, this is wrong. We need to var equals spawn var, and then we need to return the var. Okay, and then um, unify takes an env, takes an a and a b. Okay, now we need to do some trickery. We need to check if A and B have the same type. Um, that's the first thing.
Okay, so apparently you can configure per process the garbage collection.
Oh, that's because in the standard configuration, each process has its own memory, so each process has its own garbage collector. That's not what I mean. What I'm talking about is um, the global strategy for memory management.
What are you calling a strategy? Give me an example, please.
Okay, by default, each process has its own memory, and that memory is not shared with any other process.
Yes.
So sending a value means you have to do a copy to the target process mailbox. There's an alternative way of doing things where there's a single memory space for every process. And then that means that to do a send to another process, you can just pass it by reference because everything is immutable,
Oh, you
right?
want to change that deeply the thing.
But that means that now you need a concurrent garbage collector, right? To give the concurrency guarantees that you expect from Erlang.
Yeah, that sounds like a miracle. If they actually
No, but that
had a
actually
way to configure
exists
that.
or existed at some point. Like if you look for Erlang shared memory concurrent garbage. Actually, let's just say GC. Garbage collector. That's not really. I remember reading about this at some point, but
Okay, just keep going. I can continue researching this.
okay. Is there a type operation?
But I'm very impressed that at some point that was a thing. They
Yeah,
actually
they
allowed you to
did.
swap the gears completely, going from a completely immutable and non-shared memory space to full shared but then concurrent garbage collector.
Yeah, they figured, okay, message sends are kind of expensive if you're sending large data around, right? Let's try a different memory management strategy and see if that's better. And then it turns out that actually having a separate process per a separate memory per process is still faster because the implementation is massively simpler.
Impressive. But I'm not too optimistic that that's a thing. But okay.
Yeah, they may have gotten rid of it at some point. Uh,
What are you looking for?
applications. I'm looking for a function that returns the type of a term.
Can't you just use eStuple or something?
I'd rather avoid that, to be honest.
Okay, so the function you're looking for. I actually don't know if there is a function that does that. I think they have predicates for each one.
Uh, I mean, I can understand not having that um, if you have if you have user-defined types, but Erlang doesn't. So let's see. I guess technically that would make it a bit harder to add new types. So
Yeah,
maybe that's a reason not to
they
do
have a
it.
bajillion predicates for each type. I just I think there's no way around that. They have for tuples, they have for integers, they have for atoms,
I just
maps.
ran into the same problem thinking about it now.
But actually, fundamentally, that doesn't really fix the issue because you will still have, if they add a new type, you still have a case that you are not handling, regardless of how you check the type.
Well, they may have a function that is just uses the guards, and if it's not exhaustive, and if you add a new type, it just crashes. That sounds like Erlang. Uh,
Um, yeah, yeah, this actually doesn't really give me what I want.
yeah, I don't think there will be a function that just gives you the type.
Because if there was, I could. Actually, that wouldn't be
What
very
do you want to
elegant
do exactly? I didn't.
He wants to implement the unify function in OCaml here. So essentially,
in Erlang.
yeah.
Well, what are you looking for in Erlang that you don't have?
In
Um,
OCaml, we grab the two things that we're trying to unify and we check their types. But because it's a tagged union, we do that with or pattern matchings with in its OCaml, so we can do the OR. So you know the OR patterns,
Yes.
and then we do pattern matching on the tagged unions with the types that they must match in order for them to unify. So you have I don't know a structure and a
So you want
structure.
to see. I see.
Yeah, so he wants to find a function that gives a type to do essentially the same trick. But because they are based on predicates, he got fucked.
Well, you would need to pattern match and discriminate each one of them in a case, right? Somewhere.
Yeah, you can make
yeah,
a function that calls all the predicates and returns the one that returns you an atom in the one that got true.
that's incredibly inefficient.
Well, that's one way to do it. If you don't have a function that gives you the type.
Hmm.
And I think we're gonna end up doing that.
That sounds the most clean solution, but again, I mean, how many do you have?
Google
A bunch.
says I think 10.
I
Let's count. One,
want to
two,
say that
three,
is a bunch.
four, 5, 6, 7, 8, 9, 10, 11, 12. But out of the 12, we're not gonna use some of them, such as sport
I
or
see.
beat string. Terms in Erlang are totally ordered. The Bing book says so.
Oh, I guess that's not gonna show up here, is it? If I just search for total order.
No. Let me find the Bing book page that to inform me of that. Actually, the Beam book exploits that fact that you can compare any terms.
How exactly are they totally ordered? By
They
bytes?
are no, they arbitrarily say that there's a sequence
Yeah,
of types,
yeah,
and if a value has a type that's
Oh, I
higher in the
see.
sequence, it's greater than every other.
So
And then within each type, there's an order for that type.
that is
yeah.
the label 1, 2, 3, blah blah. It can use for that, I suppose, right?
Yeah.
I don't remember where I read that, but I will find it.
So essentially, it enumerates all the atoms, right in
Yeah,
there.
yeah.
Like
Interesting.
at yeah, like atoms are sorted lexicographically, I think. But atoms are lower than functions, I believe.
Yep, yep, yep. There is partial order on all terms in well, there is a partial order on all terms in Erlang where the types are ordered from left to right in an above lattice. Wait, this is the math thing. Okay. Okay, I'm gonna send a print in the chat. So apparently it's a lattice, a mathematical lattice. So that's interesting. So let me grab the print. Okay, but why do you want to use that?
Hmm.
Here's Magetta.
Oh, I remember that. I remember what was the book that I sent to you that had those
Those what?
lattices? I
I
forgot.
don't remember
There
you
was a
sending
book.
me that. Yeah.
I think I did the Parmenter book on discrete math. It had
Oh,
that
it was
chapter
it. I think it was in. Wait.
a couple of years back. It was not recently.
Yeah, I don't remember if you sent me that. My bad.
And of
Oh,
course, floats mess everything up as usual.
yeah. Remember that all. Yeah, but they have predicates specifically for floats. So man, there is even there is even a section in the Bean book dedicated for well a paragraph dedicated for floats. Here, I'm gonna send in the chat. You can have a wet dream, Marinho. There you go. Okay, but the portion that matters that I read today's morning was remember that all Erlang terms are ordered, so these instructions can compare any two terms. There is
Hmm.
even an order between the atom self and the PID returned by the self function.
That is actually very impressive.
Well, they can get away with this because the type system is non-extensible, right?
Yeah.
Yeah, but I mean, the fact that they thought about this is impressive in its own.
Okay.
I'm pretty
Anyway,
sure JavaScript doesn't have this.
but it's JavaScript. What is the
Yes,
bar here?
that is the benchmark by which people evaluate all the things in
What
the
is the
modern world,
bar?
man.
Okay. Anyway, so what's your plan, Marinho? You can't have a function that gives you the type.
I guess we will have to make one then.
Man, just make a pattern match using guards. Like, what's the problem? It's gonna look ugly as fuck, but life.
Are you saying life is ugly?
No, no, no. That life has ugly things.
That's true.
What's the problem with a pattern match with guards, Marin?
Uh, well, I guess there isn't one.
No, no, no. You don't need to do that. You can put the guard in the function, like unify, and then they put the one before the arrow, I believe.
That is
That's
true.
that is probably cleaner. Also,
Is list a how do you do an end? Is it like this?
Hmm. I have no clue.
I don't think it
I
is.
don't think it is as well.
I don't think it is, and
You
also
gotta be fucking kidding me. It's a comma? There's no way. I think it's man.
Uh,
The AI is telling me it's a comma.
Wait, it said something about it also. I think the AI is gaslighting you, man. And
Patterns.
returns true, yeah, so it is just the end. What is the difference with and also? And also works, but quits evaluating its arguments when one argument evaluates to something else than true. Huh, interesting.
Oops.
Wait, so when also is actually, huh?
These short circuits. Although wait, that is weird. Let me read that statement again, but you go back
It is
there.
a Boolean function, so actually
Man,
it
it
looks
is
like
comma. It is comma.
what?
I think if you want to do multiple predicates, between them you put comma.
That
Well, we can check
sounds
that. Um, Earl, whatever a when
true and false.
A is equal to
True, comma,
1.
false.
Yeah, that's also works.
true false, then
Okay.
unreachable.
That just okay, that works.
Okay, that works.
Okay.
There we go.
Syntax error before when?
Yeah, can you do that? Can you just put true in there? Just put
I mean,
true
Be
greater
careful
than
that it
1,
will
man.
not be able to define that again, I think.
Yeah, true greater than
mm, I got a
1.
I got a syntax error though.
I think it is might be the comma then.
No, no, no. I think well,
Wait, before the when?
Yeah.
Huh.
does that work?
No. Before the when.
Can you put end now? Let's try.
Still before the when.
That's weird.
And if I
Ah, no,
do
no, no. Forget the comma. Forget the comma. I was reading it wrong. This is a completely different thing. Oh, I got bamboozled. Look at what was written, Mageta, and see how miserable I failed to catch it. This was the thing. And I looked at it and I got happy, but I was wrong.
Oh, yeah. That is just the patterns of the fun, right?
guard function or a condition expression. Condition expression can be a guard function, comma, condition expression. Okay. Uh, but why is
Can
it
you try to
failing?
use a? Try using a there, Marinho, on the end.
Let's just do the discard.
Yeah, that works.
I don't think that's how the end works.
That might not be, but man, I just checked and the when clause is exactly like that. So there is something strange. I
Eh,
think it might be because you're not using the argument, right?
That's kind of silly.
That sounds silly, yes, but we are in a silly space.
Yeah, it's and. So it seems like an operator, man.
Guard syntax.
You're
I'm
you're,
looking
you're
here.
calling a function called and. I don't think that's how that works.
Hmm.
Wait, what? Syntax error before the arrow? What?
Do I need to say fun? Is that a problem?
Ah, maybe that was the problem all along. Maybe.
Uh, on the
Not.
REPL, you cannot define a. Oh, right. I think on the REPL, you may not be able to define a
A
function,
function.
right?
Okay, LFA
That,
wins. Go fuck yourself.
that's kind of sad, but okay.
That's
You
silly.
probably can define lambdas because they're just values, right?
Yeah, copy the lambda that I sent in the chat, Marin.
Can't we just do then runtime Karuta, and this should spawn a shell and do stuff, right?
Yeah, but there is a syntax error in there. The second is list is gonna break shit.
It didn't, apparently.
I don't think it loaded. Try to do Karuta column and then tab. Yeah, it didn't load.
Nothing.
Yeah, it didn't load. How do you load files? How to load files in the repo? The same thing as Monday. No fuck.
Oh, you should be able to do that, but you need to set the path, Marinho. So
Ah, yeah, it's
Erlang add path
trash.
z.
Yeah, you no. Yeah, you can't just do Earl and the file. They are dumb.
Yeah, you need to do Erl and then set the path, like Erlang colon add path z.
There we go.
What?
I
Okay,
just
you
changed the
entered
directory.
inside the folder. Yeah, okay.
Yeah. Variable env is unused. Okay. For now,
Just put
let's.
underscores on those things. Yeah, I don't
Oops.
think the end also works, but okay. Okay, now it should do something about it.
Yeah, that compiles.
Okay. Try calling it.
Karuta unify
New
whatever.
Potato.
okay.
Sorry.
Potato.
Torpedo. Potato.
Potato.
Garbaggio.
Garbaggio.
And
Whatever.
No, but this will fail. We don't have a function for that. We need to put lists in there, folks.
no, I know. We are testing if it fails for that reason.
Oh, but it didn't.
Karuta
It's
Uh,
undefined.
unify is undefined apparently.
Kill the
and
kill
if
the
oh, but
repo
wait,
and
he
start it
did
again.
recompile.
Yeah, I know, but
That
oh, you
should
didn't
be fine.
export
Oh,
the
you didn't
unify.
export. Yes.
Actually, that
Export
makes
up there.
sense. In that case, yeah, let's just do it. Export, unify. We're gonna need it anyways, maybe.
Probably
Maybe.
not. Probably not. Yeah, non-exhaustive
Yeah,
pattern matching.
Pause.
and
Perfect.
if I do this should work. Yeah, it gives
Damn.
me an okay.
Put
Okay.
only one as a list.
Good test.
Actually, Garbaggio. Let's be
I would say
fancy.
put the first, but okay. Put only the first as a list.
The first,
Do you have anything to fail, like a fail with in Erlang? How do you raise a error
Raise.
as an expression? Does that work as an expression?
I think so.
I wanted to test if it will actually evaluate the second guy.
Oh, there is a.
the second guy, what do you mean?
I want to know if the end also tries to evaluate the B, the second side of the clause, if the first fails, right? I think it short circuits.
It short circuits, but this is restricted because, like, you can't just call arbitrary functions in a guard for some reason.
That's strange.
Oh, wait,
Oh,
can we
right.
test the
This
comma? No, no,
looks
no.
like functions, but they're
Can,
not really,
can
right?
we
I
test
tried
the
to call
comma
them
now? Can
set.
you swap the end also for a comma? A lot of people are telling in the Stack Overflow that the comma was the original way to do it. Can you try to compile this again?
That looks ugly, though.
Yeah, so. Well, they kept
That
the
is weird.
semantics of the prolog syntax for the guards. Because semicolon is the or
Yeah,
in guards as well.
strange. I mean, I would rather just type end because it's weird to have the same piece of syntax meaning two different things.
Yeah, there's a whole discussion here on Stack Overflow about using comma and end also.
Okay, let's just go with this, man. So,
Yeah, I think and also is the one that people are suggesting. Cool.
Okay, let's say to do, and let's add a bunch of clauses.
Okay, so what are the types that you care about? So atom, for sure. Binary, I don't think we should care. Bit string, I don't think we should care. Floats, I think we should care.
Why not?
Well, because that means that. Well, I guess we could because we can, and I don't see a reason why not.
Like they're all immutable lemmos. Why not?
Okay, so let's start from the top. So the first ones, let's do atom. Let's follow the order that I have in here. And then the one next is binary.
Uh,
The one next is bit string.
Technically, every binary is a bit string, so we don't need two cases.
Float.
Uh, this is kind of
Wait,
redundant, but okay.
function. Are you gonna have high order predicates now?
No.
Okay. Integer.
Um,
List.
we have
Then
list.
map. PID.
Is map a actual thing?
Yes, there
It
is a.
is.
Yeah.
Oh, interesting.
Port.
I never
Reference.
understood the difference between a port and a PID yet.
Yeah, me neither. And a tuple is the last one.
What would be
Okay.
tuples in Karuta?
Tuples is how we're going to encode
Functors probably.
functors, yeah.
Yeah, that's all of
Okay.
them. That's all that the AI gave me.
What is the reference though?
Great question. I have no clue.
Oh, you can search for it. Is reference.
So
Very explanatory.
ah,
Oh, but we can see what make ref is. That helps.
does
Make
that?
ref. Returns are. I see what it is. This is basically Jensen.
The reference is unique among connected nodes. Oh, I see. So before UTP, made it multiple times. This node reference is
And
created a
what is
new
that? I don't know
instance.
what is that, Marin.
It's like an atom, but it's guaranteed to be unique each time you call this thing.
It's probably for the connecting multiple things on the network, right? Well, uh, it's literally saying nodes, so
Okay.
you need to know who
Let's.
is which service is which, right?
It's
Okay. Let.
like creating a name in Oz.
Ah.
Name
Okay. Okay. That
nodes.
makes sense. Okay. Let's
Atom
start implementing
content.
those things. So the first one is atom. That should be pretty cool, pretty easy to do, right? Just comparison.
Um, yeah, when they're all like the atomic types, and by atomic I mean the ones that don't have any internal structure, they all have the same implementation actually.
It's just
So
equality, I suppose, right?
Yes,
yeah,
just
it's just
equality.
equality.
No. But
Binary, bit
no.
string,
But there are two
float.
types of equality in Erlang. We should care about that.
Oh
There are
yes,
two.
that's true.
So
There are
there
two types.
is.
Why?
Yeah, there is. Is.
Look for the rabbit
Yeah,
operator.
the
That's probably
rabbit.
the one we want.
Okay, so this is the thing. Read the chat. This is the thing.
it yeah. It looks like a rabbit, that's why rabbit.
Yeah, it's in
With
the
the
chat. The
whistles.
answer, Marie.
Whistles.
If you want to make sure they are compared different, you can use ECQ blah blah blah. Those correspond. I see.
Bean book, folks. Bean book.
Okay.
The big book. Is there a physical version of this book?
Uh, Let me
How
check.
do we do an OR guards?
What do you mean by or? It's semicolon instead of comma.
Or you can type or
Or
else.
also. Or else. I think it's or
There's
also,
or
right?
else. Not sure about or else. I read or else on the.
Okay, but
It's or
what's
else.
the
It's or else.
precedence?
Oh, true.
Well,
Actually, can I do parentheses here?
yeah, I think you can.
Problem solved.
Is that really or
Uh,
else? Can you check that, buddy?
it should be.
Or Erlang. Okay, so what the fuck is an or else? Oh, it's short circuit expressions. That's what the name is.
Short circuit expressions. Oh, there is a or else.
No, there is.
There you go.
Works, but quits evaluating as soon as one of the arguments evaluates to true. Yeah, that is it then.
Okay, but why would you not use this in place of the or and the and?
Returns true if any of the arguments evaluates to true. Oh, because one, it tries to look at all of them. Oh, but wait.
Yeah.
Evaluation order
Returns
is
true if.
undefined.
Ah, that's
Ah, I
the
see.
difference. Okay.
That looks evil, to
Yeah,
be
but I would
honest.
never use that then. Instead, I would use the new.
Yes.
Yeah.
Why is that even an option, right?
It's an
Don't
option
understand.
because if all the expressions are pure, then you can let the compiler figure out the most efficient way to do it.
All
Okay,
right,
that's
and
fair.
then yeah, then you just try to simplify for the one that is easier, right? How would it know though? It needs heuristics if it's going to do
It
that.
probably has heuristics.
Well,
Let's
I
continue.
have
Let's
my
continue
doubts,
the
but
code
it
there.
might be. That doesn't sound very trivial.
Okay, so or else, and then we can get this. Man, this is going to be kind of big.
Not a problem. Just put the or else on the end of the line. Yeah, enter there. Yeah, exactly. Let's keep going. Okay, so what are
Oof.
the types that we are not going to do the equals just that? It's going to be the map and the lists, that's it?
And tuples as well.
And tuples. Okay. We're going to call the function recursively, I assume.
Yes, we
Okay.
must.
Okay.
Oops.
Yeah, it's
Or
syntactically
else,
more verbose than OCaml version, but it's essentially doing the same thing.
We want to believe it is.
or else. Um,
How are we going to do, which type is going to represent references, Marinho?
PIDs, unfortunately. But we also need a side condition on that they must be present in the environment.
That's fair.
Is reference as well.
What's going to be a port?
I suppose technically we can use a reference instead, and that's guaranteed to be unique, which solves some problems with using PIDs.
Oh, okay. So we put a
The problem is
fail.
that
Go.
the problem then is that if we use a reference instead, then hmm, references are just small constants, so we would need to put the state somewhere if we do that.
Yeah, but you already have that.
Which,
It's the environment.
yeah, I'm thinking maybe we should use references instead to refer to references, I guess.
Sure. Yeah, but
Ports
I think we
provide
should
a basic.
go on, Magit.
Uh, I was just reading the docs. Ports provide a basic mechanism for communication with the external world from Erlang's point of view. They
So
provide a byte orient.
we should use
A
ports for the
byte
talking to database
oriented.
then.
Uh, well, the database is inside of it, right?
Oh, it's gonna be a separate thing, a separate process, right?
Mm, yeah, it's a separate process inside of itself, inside of the VM, right? What it's
Mm.
suggesting is to use it like you have a C library, for example, and you want to interface with it. We probably do that on Lyceum, and we don't
Yeah,
know.
let's use references actually. That solves a bunch of problems.
Okay. We should put a problem if we have PIDs though. So, like we should have a catch-all that fails.
Uh, oh, actually, that means references should be treated as specialists, so they shouldn't be here. They should
They
be in a
should.
separate case.
Yeah, that's true. I don't
Yeah,
know if we use
PIDs.
ports in there. Magito. I don't remember that term from that time. But I also can
I
be
don't
mistaken.
remember either, but I think we might be using it somewhere.
Maybe in the C library that Zero uses, it's using a
Yes,
port and we
that's what
don't
I'm
know about
thinking.
it.
If it's a PID or if it's a port. Ports are basically identities, right?
Well, Magenta just read
Uh,
ports are things
yeah,
dedicated for the external world.
they look like binaries. I think that's more fair to say.
They look like binaries. Can you pattern match on them or something?
I think you have equality on them. Let me see. Port drivers, open port.
Yeah, is port. Let me read. Uh, yeah, port identifier.
Yeah, okay, so ports are more like actually they're more like PIDs.
Oh, if they're like PIDs, then that's fine, actually.
In the
Oh,
following
big
example
big
must be an I
surprise.
only.
The AI lied. There's more predicates.
Oh, fantastic.
There is boolean, which is the
Why the
But
heck?
that's no, but
We can ignore booleans.
is boolean is redundant because booleans are atoms in Erlang.
is that written in here? No, they only treat the okay. The is boolean only cares about the atoms true and false. It's written here.
Yeah.
There is a is
But
number, by the way. But I think we should. It's better for us to differentiate floats and integers.
oh,
That's
bit
better.
string. That
Yeah,
we need.
yeah. Bitstring we are already using it. Yeah,
We
and the
probably
only one that
don't.
we are missing in that list, Marinho, is
Oh,
record.
wait. Do we have binaries?
Yes, we
Because we
have.
We
can't
have
pattern match binaries, so unifying on binaries must sounds insane,
No, but
but
then
not if we. No, we can. We're going to treat binaries as atomic values. We're not gonna
okay.
do like yeah. No, that's silly.
Let's see.
Yeah, this is redundant actually.
are we gonna do records? Because that's a predicate in here is record.
Records are tuples, Lemos.
No, yeah, but they are treated differently. Magenta just shared this news with us today.
Wait, records treated differently than tuples. Well, records are like I like maps, right? We've annotated with an order. That's the only difference that they have an order. But
No, records are tuples behind the scenes.
wait,
Yeah.
are they tuples?
Yes, yes.
They are.
We use them in Mahjong, man.
No, but wait, they cannot be tuples because they have keys on them.
That's synthetic sugar, Mageta.
Oh, that's
Yeah.
just syntactic sugar.
No, no,
Kill
no,
me.
no. But you read in the Erlang book that they are treated differently, and there is a note here also explaining that records are treated differently.
Oh, the guys just said that was on the designing for scalability OTP, right? He
Yeah.
just says that you should prefer to use records instead of maps, but he's comparing with maps because they are well, they are used for dynamic
Yeah.
objects at
In
runtime. Right?
Lyceum we used maps at the time, but in Mahjong we are using records.
Well, if you're doing like relatively small data structures, the size difference is not that big, but records are definitely smaller.
I thought records would be like C structs in here.
Well, the equivalent of a C struct is a tuple, so that's why records are
Yeah, so they're
tuples.
the same. Interesting.
Yeah, but I don't think we need them, right? We can keep the unify function without them. So let's just go on.
Makes sense. Tuples are also positional here, right? So
Is atom, is bit string, is float, is integer, PID, part. The other ones, well, reference needs to be treated especially, and lists, maps, and tuples are more complicated because they have contents.
The fallback should just return the environment, right? In line 41.
The fallback. The fallback should just return the environment. I mean,
Yeah, because we're not gonna do anything with it, right?
well, if the unification fails, we need to backtrack. We need to signal that somehow.
Well, we need to talk to another process, I guess.
well, you can just return, right? In that case, we don't need to talk to a process.
No, no, but we need to signal to somebody that we need to do backtracking immediately after this.
Yeah, but this can be.
In
Oh, but I
Karuta,
see.
uh,
Well, the way my input there, I don't think we can. Right.
no, we need to do something in
We need
that
to
line
do
40 there.
this. Yeah, this way we need to do service, right?
Uh,
yeah, no. For this to work, we need to say. Yeah, we actually can't do it like this. I think because if we
what's your
do,
alternative?
Like, I mean, putting the tail call outside of this case, because then we can't check if unify fails, which means we have to rely on side effects to backtrack.
And you want to do variable behavior to do the backtracking. Well, to call the backtracking.
Well, we need to. Well, ideally, we should variable behavior. Variable behavior.
Yeah, but
Actually,
let me just explain to Magenta how we did this before. So Magenta, in the OCaml code, we also have a unify function, and the unify function sets a boolean in the computer that signals to the evaluator later that we should backtrack. So that's how we do it in there. But in there we
Okay.
had a computer. In here we don't have it. That's the difference.
but variable behavior needs to tail call itself regardless, which means there's no way around sending a message to signal the unification failure.
Yeah. Yeah, that's why you answered me when I asked. Okay, unify has no output. And then you said, oh, we're gonna signal the backtrack via message sending. And I was like, okay.
Value PID. So PID, whatever. We need to say okay, value, and then tail call, and that means
That means.
actually if we do bind here, we can just return the okay, I think. Let's say okay value, that's more uniform, probably.
Yeah, we should keep it as that. And the unify, what we're gonna do? Just send the PID as well? Send
Yeah,
it
we're
to
gonna
the
need a
PID.
PID. We're gonna need a PID. And that means Unify also needs to take a PID, actually.
Don't forget to do the send. PID exclamation mark. Oh, you actually just want the unify to do the send. Why don't we do the send ourselves and the unify just returns a tuple?
That's probably better, actually. PID, bang,
Yeah,
there.
now it's more consistent. So there will be a third guy that will be responsible for doing something on the failure of the behavior.
Yes. Yes.
Okay.
Mm, let's just return an OK on bind. That's actually, I think that will be better because then Unify doesn't have to keep track of what was the top level value.
Sure.
That's simpler.
Sure. Okay, so let's continue the
Uh,
unify implementation. Well, let's just start by putting on line 41 an error, right? Just return an error in the fallback.
return an error in the fallback.
And you can put underscores in instead of A and B in there. And don't forget to remove the when.
Error, unification failed, A, B.
No, you want to use them. Okay. Uh, don't remove the when above, and that's it. Okay, so on the unify with the big or else, we just use which equality we're gonna use, the rabbit or the?
The
I think.
rabbit because
Yeah.
well, actually, do we need the rabbit? Because this is gonna fail if one is a float and the other is an integer.
But is that possible? We're doing and alsos and or else's with parentheses. I don't think they can be different.
They cannot be different, which means we don't need the rabbit. We can just use equals equals.
Ah, okay. Okay. So, tuple, okay, and then the equality there. Okay.
There we go. And then we return okay.
Okay, in the case of the references, what do we do?
In the case of the references, um, in the case of the references, if they are actually equal, then we can just return OK. That means, in fact, we can put the reference case up here as well.
Sure. Yeah, but there was a case that they were not equal, but we need to like walk through it, right?
Yeah.
Oh, we need to do dereferencing. I
Yeah,
see.
if one of them is a reference and the other one isn't, actually it doesn't matter what the other one is.
Yeah, but you're gonna have to copy paste this code because maybe this first one is and the second one isn't, or vice versa.
Can we get around that somehow?
Uh, we can get rid of change the end also for an or else on line 33. But then we're gonna have to check again to know which one to walk through.
We're gonna have to check again. Hmm.
I don't think there's a way around that.
We can make a helper function, actually.
Of course, that's also works. That also works.
Unify variable. We actually going to need the environment here. Env a b. But then if b is a reference, we swap the order.
How do we plan on mapping structures to Erlang?
Tuples.
Oh, so we're gonna use functors and structures to be tuples in here.
Functors and what do you mean?
I remember that in the ref cell, we do special treatments in if they are functors or if they are structures.
Oh, that's because when you see a functor, that's not a proper reference to a value. That's a header that belongs at the beginning of a structure.
Yeah, but we need to do the same thing in here, no?
No, because the type tag already does that for us.
The type tag. You mean the tag that's gonna be within the tuple?
The tag that's gonna be, well, yes, but also the length of the tuple and the fact that it is a tuple and not something else.
Okay.
If A and B are tuples and also they must have the same size, we can get away with that. Is there a way to get the length of a tuple?
Yes. I just don't remember which function.
Tuple size. Tuple size of A equals tuple size of B. Actually, do we need a unification failed here to include the A and the B? I don't think we do because the caller is going to know, right, what it passed to
Yeah.
unify.
Yeah, I think so.
Yeah, so this and this are ignored. We can probably do something similar for maps, actually.
Yeah, but what is the function?
And
Map size?
also,
Yes, map
I
size.
think, yeah,
Yep, map size. Yeah, but now we need to compare. Do maps have equality?
they do. Of course they do.
Okay. Wait, but this means that we can also use we can put them in the big unify up there. But that's gonna look ugly. Let's not do that.
We can't actually.
Why not?
We can't. Because if the value of a key is a reference, and that reference is meant to be a variable, then that needs special treatment.
That makes sense.
That needs freaking special treatment.
Same thing for lists, right?
Same thing for lists. Actually, we probably need I guess unify variable can be responsible for. Actually, it shouldn't.
That's the question.
If we're unifying things that are variables, they need to be dereferenced actually at some point. Let's not worry about that right now though. So for lists, actually, we don't do that. We do something else. Let's implement the list case first actually, because that's easier.
Wait, don't the lists
Uh,
need to have the same length as well? Ah,
they
no, right? Because you may have the tail being a variable, and that may match with the tail with the other one, which is not a variable, and that's different. Yeah.
That is a concern, yes. And a secondary concern is that getting the size of a map or a tuple takes constant time. That's not the case for a list.
Oh, of course, of course.
Always.
Okay, so what are we gonna do about it?
Um, what are we going to do about it?
Aren't you gonna do a
Um,
fold recursively on the function?
try. There's a try syntax, I think. Exceptions. Let's look here actually. Reference manual. Blah blah blah. This is
Errors
not what I
in
wanted.
error handling. That's the name. That is the
Oops.
name.
Here. Here. Okay, try and catch. Uh, exit reasons. Um, distinguish blah blah blah. Okay, so if we do okay equals not okay, no match of right hand side value. If I do a try and I catch E, E, that, oh, I need an off, okay.
And I need an end.
Actually, no, the off is only in case it actually works. And I need an end, that's what was missing. That
Okay.
didn't catch, actually.
That's weird. That's very,
Um,
very weird.
but there's no matching exception pattern.
Can you
There's
go
no
back to the
matching
terminal? They have an example here I want to compare.
back to the terminal.
Yeah, so try, blah blah blah, catch, variable. Yeah, this should work, I think. Yeah. I don't know what's wrong.
Oh, right. Ret. Ret is not bound, yeah. I figured. I
Why the heck?
figured.
No.
Try Mageto?
There was a neat trick I wanted to try, but that's not gonna work, I think. Case, unify. Actually, we don't need this, do we?
What do you mean?
Because we can say this is empty and this is empty. Um, then okay. And then we do. Oops.
New approaches. Oh, Lemos came back.
Yeah, Marinho was robotic.
He's Robloxing for me a little bit.
I think
Then
the
we
order of the
do.
pattern matching matters, Marinho. We need to do the empty lists first.
It doesn't. In this case, in particular.
Ah, okay.
Head of A, tail of A, head of B, tail of B. This is redundant.
That's true.
Env, age A, age
HB
B,
off.
of. Okay, okay.
That sounds so evil.
No, no, no. Okay should
Actually, not
follow
okay. It
recurse.
needs to
Yeah, it's not
be. Yeah, it
okay at
needs to
all.
recurse. Unify, env,
That sounds evil.
tail A, tail B.
It's not
Otherwise, it's
okay,
going to
folks.
be an error.
You're missing the semicolon at the end there.
Yeah, I was about to say that.
Semicolon.
Line 29.
Semicolon
Yeah,
here.
there. That's it, right? That's pretty much it. So Magetta, just for you to understand what the fuck we're doing, again, just to, even if I'm repeating myself, we are grabbing two things, two variables, and we're
Mm-hmm.
implementing unification on them. So if they are literals, we need for well, if they are collections such as lists, we need to go over
Mm-hmm.
them to see
Yep.
if they unify, and they may have mismatching types. For example, one of them could be an integer and the other one could be a reference. But if you
Yep.
dereference the reference, it may be the same literal. So they should
Mm-hmm.
be able to
It's the
unify
same.
them.
It's the same as the Hindley-Miller unification so
Really?
far.
I didn't
Yeah,
know that.
it's awfully, if not the same, very similar.
Uh, okay,
Yeah,
we need to.
go on.
Hmm.
We need to implement unify variable.
We need unify variable, but before that, we actually need we need to change the entry points here because this is not quite what we should do. What we should do instead is unify uh, env a b unify um, dereferenced env we need to implement deref basically env a deref env b.
Wait, so we're gonna actually do the deref before calling the second unify?
Yeah, we need to do the deref before
Well,
we
to
call
to be
this
to be
and
completely
this.
fair, that's exactly what we do in the OCaml version. Like
And the
we quite
recursive
literally
calls.
deref first, and then we try to do the pattern matching.
Yeah, the recursive calls still have to be like that. This and this. There we go.
You missed lines 41 and 42.
Those needs to be unified actually.
Oh, because you need to dereference more of them, maybe?
Because we know that these lists are not references, but they may contain references.
I see. Okay, so let's implement dereference. So the way that we implemented last time. Okay, let's actually look at the OCaml code. I think that's easier than trying to remember. The way that we implemented that last time was we check. We're gonna be using predicates again, of course, because we don't have pattern matching in here. So where? Yeah, here it is. This is the code that we used last time, Marinho. I'm gonna paste it in the chat. So I think this could serve as inspiration for this version. But instead of pattern matching, I'm
Uh,
gonna be using guards all over the place.
receive.
Oh, this is the process that's gonna call the variable behavior process.
Yeah, new variable. Um,
var
var PID.
PID, yeah.
Let's say that the state is a map, which means we should do environment behavior. Um, and I learned that actually we can do this state
Yeah, that's
var
probably syntax sugar.
PID.
Yeah, but what other
Semicolon.
kinds? Yeah, what other kinds of messages can we receive? We can receive an OK, right? Literally, just an OK.
An OK. Why would we receive an OK?
Line 16.
That's not. This is not the environment, Lemus.
Oh, but I just asked that question. Is this gonna be the process that calls the variable behavior? And you said yes.
No. The PID. The PID here is a process that's running variable behavior.
Ah, okay. I see.
If we receive dref var PID, then we need to send back this PID is not actually a variable.
Wait, sorry. What
We
was
can
the question?
just okay. If we try to say okay dref a var, we need to okay. There's a neat thing we can do actually. If we
Oh,
dref a var,
wait. I have a question. Who is
okay.
sending this dref tuple to us?
Unify is going to need to do this actually.
Oh, so the dref functions on line 30 are misleading. These are sending messages to this guy.
Dref where?
Line 30.
Line 30.
Those are not
Uh,
functions. Those are message sending to environment behavior.
we need to do a message send, and then we need to wait for an answer from the environment and return that basically.
Okay, so these are not functions. Got it. Okay.
Okay, if we get a dref of a var on a given PID, then well for a given PID, which is the sender of the message, that means we should we
Does
need
the
to
is the
look
state
up
the
the var.
environment? Yeah, is the
Yeah,
state is the environment.
the state is a map of reference to PID, basically. It's the actual mapping that the environment is keeping.
So we need to do a lookup.
We need to do a lookup, yes. Um,
No, but it's a recursive lookup. Because if you do the first lookup and it's another it's another var, well, it's another process that variable behavior, but it's another reference at the end of the day. We need to keep doing the dereferencing. Remember that?
yes, there's a neat way to do that. I'm just thinking we may receive references from outside of Karuta eventually, right?
Well, I don't know how we're going to implement the database, but do you imagine that's going to be a thing?
Well, if we ever want to interoperate with Erlang or other Beam languages at all, like this may happen.
But I don't think we will, because the semantics of our language are completely different. But okay. So your idea
Uh,
is that the environment behavior process will be doing the deref for us. And it's going to be doing that by doing lookup in its state, which is the environment. And then we need to ask we need to, yeah. There is an orchestration of process going on in here, I see.
okay, I think I know what I'm gonna do actually. So if we maps page. Maps are records, blah blah blah. Maps as dictionaries. Maps merge. Maps as sets, how they are implemented. Yeah, this is not what I wanted at all, actually. Here. Um,
What are you looking for?
is channel. Is there any syntactic sugar for doing a lookup on a map?
Yes, we used in Lyceum. It's pattern matching, essentially.
So the pattern, so the syntax sugar is the pattern match.
Yeah, you do pattern matching on it, and you can destruct the keys. A little bit
The problem is that
worse than
if you just do that though, well, I guess. Hmm. Yeah, the problem of just doing that is if the pattern matching fails, we need to treat the error, right?
Just put case state off, and then we do the first pattern matching of the case with the destructuring, and then we have a fallback that we can do the treat the error. Here's
That
how it
should work.
works. I'm gonna send it in the chat. You can just copy paste. Here's how that works.
Var. Um, if we have a var,
Oh no, wait. No, that's not how you do that. My bad. Yeah, that's.
behavior.
Let me look at how we're doing this in Lyceum. Well, here that's the problem. Maybe we need to change that. Oh, here it is. Thank you. They actually thought of that. Here, the indentation is fucked, but you can figure it out, right?
Okay, if we have a var with a given behavior, then that means we need to do read of the behavior. We need to do a read of the behavior.
Wait a moment. The behavior is always a PID, no? The PID of the process doing the variable behavior loop.
We need to do a bunch of nested cases basically.
I'm still confused. The behavior is a PID or not?
The behavior is a PID, yes.
Oh, okay.
Read self.
Uh-huh.
Actually, this is not how you do it, right? We need to do another receive. Ugh.
Oh yeah, actually that's true. Yeah, but we already learned this lesson. The syntax for Erlang sucks. That's why one of the reasons LFA is better. Like there's no way around this. You use a dependency, right? You install Erlang.
Okay, so oops.
And even
Yeah.
with Erlang, we can't fix this thing because this is using receives in the middle of the thing.
Then
Receive.
we need to do okay. If we send a dref var PID, yeah, we actually need to do this, unfortunately. Receive if we
Are you
get an
understanding
okay
the madness
with a
that he's
value.
writing?
I was actually reading something else, but I'm looking sporadically
Okay.
to see if I'm following, and so far it's good.
Okay then. It's just because if you have any questions, please feel free to ask. Because
No,
believe it
no,
or
it's
not, I
fine.
am
Now
following what he's writing.
it's a good time now that I'm looking at this because I am catching up with the months that I was
So,
unaware of what you guys were doing.
well, I was about to say suffering, but unaware works.
If we get an okay with a value, that means we need to do a recursive.
Yes, with ourselves, by the way.
When is reference var. Yeah, there we go. Okay, if we receive an okay with a value, then we
Send a message to ourselves.
send a message to ourselves
Yep.
where
Dref
dref
value
value
uh,
PID.
PID. Yeah, we are using, at least we're gonna tail call this shit because we could do another receive and then send to the PID.
If you get an error unbound, then we need to send back to the PID the variable
So there we go.
var and
It's not so bad. I've seen worse.
I'm not sure if I
Yes.
followed the last part. So if you are unbound,
Okay, let me explain.
you're
And
sending which
Marin, correct
variable?
me if I got it, okay? Magenta, here's what we're
okay.
doing. The environment behavior is going to be the guy responsible for doing the dereference. What is that? If you have a
Mhm.
reference in quote unquote memory, we need to walk
Yep.
through the pointers because that's essentially what the references are working as, pointers.
Hmm.
And then we need to keep walking the pointers until we find something uh, until we find something. So
Yeah.
what are we doing? If you on line 8 you ask for a deref for this particular var, and PID it's
Hmm.
the identity of the caller, we check if var is a reference. If it is, it means that it may be contained within the state of the environment behavior. So we do a lookup on the case of the state on line 9, checking if we found something that correlates
Uh,
this reference
well,
to
one
something
question
else.
before.
Yes.
So your guys are using the is reference to see if this guy is a node. Is that it?
It's because we are using the is reference, a reference type built in from Erlang, to represent variables. Well, reference to variables.
Oh, I see. Because they. Oh, I got it. So,
So then
okay,
we do a lookup
that
on the
is.
state, which means that we check if this var existed before. Then
Just
we
one thing. It's
go on.
because that reference is literally just an atom that is unique, I suppose, on the
Yeah.
Yeah,
Yeah, you can think of it like
instance.
that.
yeah. And then on line 10,
Okay.
we are talking to the variable behavior because what's going to be saved inside the state is a process ID that correlates to the variable behavior process, which is happening on line 18. That is a guy mimicking if the variable is bound or unbound or so on. So in line 10, we talk to this guy and say, hey, I want to read this variable. I want to read you,
They're
actually.
basically looking what is the process that wants to read that variable right now, and
No, no, no.
then
We already know the process. It's the process behavior on line 9. If there is a
and where.
var
Yeah,
as a
so
key to
that
this
was my
value,
point.
yes.
You're receiving which variable, and then you see which PID wants to read that variable,
Yeah,
right?
and then we want to do an operation on it. So we say, hey, I want to read you on line 10. And then on the line 11, 12, and 13, we receive the answer back. If we receive an OK, this means that we got a bound value. So it's already like, it's pointing to something that is on a pointer, essentially. And if you got
Yeah,
an
understood.
error,
So if it is,
mm-hmm,
and then if it is another var, then you just need to do all the thing again,
yeah,
right?
if, because there may be that the pointer is pointing to another pointer.
Yeah,
So then
yeah,
we need
I
to
got it.
recurse. And we're doing recursion
So,
in the most Erlang possible, which is sending a message to ourselves.
but wait, going back to line 12, so you're sending to yourself
Yes,
the deref
yes.
value and then PID. That should be the end of the that should be the termination, no?
Yeah, we need a termination case. Marinho hasn't written that yet.
Okay, so
The
this is
value,
just
yeah, the point is that the value may be another reference.
Yeah, exactly. But we need another pattern match in which a line 8 is without the guard.
yeah, we with the in the global scope, right? That
Yeah,
was my
exactly, exactly.
okay.
But that's essentially what we're doing. We're crawling through pointers all day.
Yeah, yeah, makes sense.
Okay, let's do the base case, Marinho, which is the one that is a
Actually,
deref, but the var is not a reference.
actually, if var is not a proper, it's not actually a variable, we need to do that as well.
Yeah, that's the base case.
Uh, and we need to do. I think I'm actually going to do something very similar here, where environment behavior, and input this here, And then instead of doing the tail call, we just return the new state here, actually.
Yep.
This is a bit complicated to read.
Oh yeah, but welcome to Erlang.
Oh, this is
Yeah,
just gonna
because
loop forever, basically.
Mhm. So you're trapping the state, and then
Yeah, we're just looping ourselves because we would have to do this in every single branch. So
I
every
see.
single
Um,
branch we call ourselves, so we keep looping to keep the process alive.
actually, we don't need this here.
Yeah. Okay, but we need the base case. We haven't implemented the base case.
There are two base cases, actually.
Well, the first one is if you're calling a deref and var is not a reference, right?
Um, yeah, if var is not a reference, that's actually an easy base case, but there's the base case for this case here as well. Um, where if var
Uh,
is not found in the state,
oh
that
yeah,
means
there's also the possibility. Yeah.
actually that
We
we
have to
need to
bind it.
say no. If the var is not in the state and we're trying to deref it, that means this is not actually a variable. This is just a reference.
Wait, I'm confused.
Oh wait, if you're trying to dereference, but the variable is not a
In the
what? I
state.
didn't follow that
Yeah.
menu.
So he's saying that you see line 10. What if line 10 is false? That's what we're doing. But I don't
So
understand
if
the answer. So if the
so
variable is not inside the environment, what do we do, Maria?
Uh, that means
isn't
that
it?
this no, it's not a variable. If this is a reference, but it's not in the state,
Yeah.
Mhm.
which is the environment map,
Yes.
that means that this is an Erlang reference that's not actually a Karuta variable.
Makes sense.
Ah, okay, that makes sense. Cool,
Because
cool,
there's
cool.
no such Karuta behavior, no such Karuta PID that is requesting access to this variable, right?
Yeah, yeah. Somebody's trying to do bullshit. Okay. But shouldn't we throw an error in that case? Why are you sending the var back
I
to the caller?
Because we may eventually get references from like external things that we're integrating with.
like
Okay.
compiler services, maybe.
Well, Domino, definitely. Because Domino will
Uh,
probably have
I don't think it
variables
would.
that won't be Karuta variables, maybe.
No, not variables, references.
References, sorry. No, but they are variables in the nomenclature that we were using before. But okay.
No, 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 no. There's a difference between an Erlang reference and a Karuta variable. Those
But
are
we
not the
are,
same.
yeah, but we are representing the Karuta variables as references, aren't we?
It must be a reference that is bound in the state of the environment.
Ah, okay. I see my mistake. Go on, Magita. Question.
No, no. no.
Yeah.
I was thinking of if Domino will actually make use of the environment variables. I think not.
Well, we must at some point understand, okay, you were receiving data from the database. We need to do something about that in the variables. We're gonna have to do that at some point.
I'm trying to figure out another big problem, actually, which is um, if every message implies in a copy, then what if I receive a large table? You see, a large relation.
No, but we're not gonna do that. We're gonna be doing some pagination.
Yes, but I'll still have to copy everything. You see?
Yeah, well, you're gonna have to copy some of it, but not necessarily all of it, because you're gonna paginate the output.
I think Minija already has continuations though, which is kind of like a pagination.
Okay.
Well, anyway, I'll go have dinner. Be right back.
Oh, there's not actually a var in this case.
Yeah, it's something else. Okay, this was not that hard actually, and
Okay,
it's pretty understandable what's going on.
so we can create a new variable by adding it to the state with a PID that we got. Um,
Okay, but then we should change line 37. I feel like something in there should call the environment behavior.
it is here.
Oh, the env is already the environment behavior. I see.
Yeah, when we start the program, we spawn an environment behavior process, which is an environment, and we just keep passing that around throughout the lifetime of the program,
Yeah, but the
basically.
one that's gonna kick this off is gonna be OCaml, right?
Yeah.
Okay. Okay, we need to change line 42 now, I think, because we are saying that we have a function, but we don't. This is a process.
42.
Yeah.
Dref.
We need to swap those dref function calls to send messages to the environment behavior.
Actually, we actually need, um, hmm,
No, just send messages to the environment process. Easy.
dref, blah, blah,
It's
blah,
just gonna look a little bit nasty because you're gonna have to do nested because it's two variables.
and variable. That means we send to the environment request to
Dref
dref var
self
self.
receive. Well, comma receive. What are the options? Either we
Actually,
have.
here's the problem. We can receive basically anything, which means we actually shouldn't just send the value straight. We should wrap it in a tuple.
What do you mean?
Um,
What do you mean in this case? It's always a single value. What's the problem?
it's always a single value. The problem is, do we expect to receive a message from somewhere else?
I don't think so. So this is always v. Yeah, v returns v. There we go. Perfect. So okay, this is actually pretty neat. Yeah, I
Let
think
me send a dref.
I think this is
Yeah.
pretty okay. What else are we missing on the function below? Unify dereferenced.
Let's see. If they are both references, it's fine. If one of them is a reference, yeah, we need to implement unify variable actually.
Okay. Yeah, but this is going like relatively straightforward. It's not even that complicated in terms of like we're orchestrating the process is pretty good in my opinion.
Is variable var pid.
And this is a lookup.
This is just a check actually.
This is pretty awesome, man. We are implementing this like very organically using the processes.
PID is reference var, and we need to do an end here actually.
So just and also.
Um, is and also just an operator as well.
Yeah, but it's short circuiting.
No, that's a thing that you can use in a match spec, but this is just an operator as well. Let's check that actually. True and also, actually false and also true. Oh yeah, that is an operator, okay. If it's a reference and also, do we have a map function?
That does what?
Maps. That checks if a key is part of a map. I think there is, I just
Is
don't
key.
remember the name.
Is key.
Is key.
No, but you
Is
need to put the
key.
maps column. Maps column.
state var.
Pretty much. Let me just double check. I am very, yeah, is key. That's it. So unify a variable. We need to check if both of them are variables first, right?
Well,
No, so
unify
if one of
variable.
them, if the first one is a variable actually.
No, we are not gonna call this anywhere else. We know that the is a variable because of how it's being called down here. Well, actually, we need to check if it's a proper variable, right?
Yeah, we need to do the lookup.
Right.
Case. Well, no, send to the environment first.
And
Tuple is variable.
is variable
A,
a self,
and then comma receive, and then we can do the pattern matching on true and false. If it is a variable, what do we do? A true variable, I mean.
if it's a true variable, then we need to bind it actually, which means in
Talking to the
fact,
variable behavior. Which means that we need to send to the guy. Okay, now we need a tuple. Oh, you're gonna be doing it via the environment behavior, not via the variable behavior.
yeah, I think it's better if the only the environment talks to the variables actually.
I think that's better as well because that means that we are kind of mimicking being global.
Bind var value PID.
You talk to the other guy there. Oh, you need to do a lookup first.
When is reference var?
Do the lookup.
Yeah, let me do case state of.
Yep.
I just need semicolon.
Yep.
Case state of var behavior. In that case, we can just forward the lookup, right? I think.
We can. We can just forward the lookup. Tail call on process level, bitches.
Yeah, in that case, behavior. We send it.
Bind.
We
Please
send
bind
it.
this guy for me.
Bind value.
PID.
And send the reply to PID. And
State.
yeah.
Comma state.
Actually, we're going to return the same state here regardless, right?
Yes, same state.
So, comma state here. And if we don't,
then what do we do? Very good question.
well, the bind, this forward is going to return an OK. In that case, we can return an error. We can return a different error, actually. Error, well, PID. Because this can return error unbound, right?
Yeah.
Actually, no. Bind can return. It can return just error from unification. Actually.
Yeah. So this is a very mutually recursive pipeline of functions. Because that calls unify. Unify called unify the reference. Unify the reference called unify variable, which calls variable behavior again.
Yeah. So instead of unification failure, We're trying to bind something that's not a proper
Not found.
variable, but it's just a reference.
Oh, just a reference. That's the name of the error. Just a reference.
Not variable, actually.
Okay. Okay, let's go down there now, back to down there, and call the bind. So if it's a true variable, we need to bind it. So env exclamation mark.
If it's a true variable, we must bind it. Actually, do we need the is variable separately?
Or do you want to immediately bind it?
Yeah, because if bind is gonna check it anyways, right?
Actually, you're right. They are kind of subset of one another.
Yeah, let's just do it. Var value PID. So that means
You directly call to
that
bind it.
env
Which is what we do, right? In the OCaml version. As far as I remember.
var value
Self.
self.
And then we do a receive. So we may have an OK.
Yeah, we may have an OK. If we get an OK, that means we unify the variable, so we just return it, right?
But we may have an error.
If we have an error, we return the error, so we just return it.
Okay. Okay, can you scroll down there? What else are we missing? Oh, you need to do the maps and the tuples now. That's the only two cases missing.
Yeah, maps and tuples, maps and tuples, maps and tuples. Maps and tuples are a bit trickier because we need to iterate. Well, tuples actually are easier, so let's do tuples first.
Yeah, do we need
Tuples.
the maps? What are we going to be using maps for?
Maps are tuples from the database. Tuples not in the Erlang sense, but in the relational engine sense.
I'm not familiar with those, but okay then.
I
Okay,
mean,
let's do tuples.
assuming that we want to handle them at that level here, right? Because maybe we actually want to turn them into positional thingies.
Yeah,
Jingle
yeah, but we can
bells,
discuss that later. Let's do tuples
jingle.
first.
Well, tuples are. Is there a map for tuple?
A
No,
There
map?
isn't, right?
we implemented one for Mahjong, which is cringe, but it works.
There's no tuple module either, is there?
No, there isn't.
Probably the
But
tuple functions are on
can't
Erlang.
we just recur? Like, can't we just grab the first out of the tuple and then recur?
Yes. The problem is there a way to do a lookup on a tuple?
Well, there is
Um,
tref in Mahjong, so probably there is a way to do it in Erlang.
Probably tuple, tuple of
What you guys
tuples.
need to do to there's a tuple to list there.
Yeah, they are list to tuple, tuple to list. Can't you just tuple to list and call ourselves to go to the list case?
I
That's
mean,
very cringe, but it works.
but
But
man, this is silly. Is there no way to just do a positional lookup on a tuple
no, that must
exposed
be.
to the user?
No, that there must be a way to do that.
The bean must have a way to do that. It does not mean
Wait,
necessarily that Erlang must expose it, is the problem.
what do you mean by positional lookup? So you want to retrieve?
Like, I want to unify each member, like the corresponding pairs of members
Oh,
from
I
each
see. So
tuple.
it can be an arbitrary length, right,
Yes,
on the
yes.
tuple, and then
Yeah.
to see if each
Yeah, and
one.
then we want to get the first, essentially. How?
Well, you can make them be a list and
Yeah,
then
that's
refer
exactly.
and then
That's
send to
cringe.
unify again.
Yeah, exactly. That's exactly what I said. But you don't know Marinho enough. He's dying inside.
It's not that bad actually, because it actually might be more.
It is linear. Oh, okay. AI is saying there is a function called element.
Oh, wait a sec. The problem is that
Oh, there is.
we would need to loop.
There we go.
So we can just do equal, right, on the tuple. So inf
No, no, no.
element
You can
of a
just do
tuple.
equals on a tuple, but the problem is that they maybe have
You can, but yeah, but you need to unify the reference
exactly,
again, right?
exactly, exactly. You're getting it, Magetta. See?
Okay, so in that case, this means. Okay, let's make a unified tuple actually. Because this is not going to need to be a tail call loop. So unify tuple env left, right, and we know they are the same size. So size equals
I wonder how
tuple.
happy Marin would be in Emacs Lisp, where you don't have tail call optimization.
Oh, of course, Magetta would say that.
I would probably try to figure out a way to run Gaia Emacs because then Emacs Lisp has tail calls.
It's silly because there's this package that it tries to convert a tail call, like with a special word like recur, into a for loop, right? But it's very silly.
Oh, just for you to know, the element function is one based, Marinho.
Yeah, actually, let's do a check here first.
If there are different
Size
lengths, it's already running, right?
equals tuple size of A. Unified tuple actually takes the size as an additional argument.
Oh, you already added a clause for tuple size, right?
Yeah, we
Actually, we
already know
don't need
they have the
this
same. We already know they
size. We
have the
need to
same
send a
size.
1 here, but we need to do a small check first.
Oh, so
If
then you can just fold, no?
Well, we're gonna end up folding, I think, but in using processes sending messages to
With
themselves.
no, it doesn't need process. Oh yes, you do need to send. You need to send calls to the unify list, right?
Yeah.
I'm just going to avoid ifs because,
Case off.
yeah,
No,
if the
that's okay.
size is
That's okay.
0,
That's
then we
okay.
return okay. Otherwise, we do the thing.
Oh, but do we need the one
And
in there? What is the one doing there?
uh, well, unified tuple size position.
Oh, this is for the fold. You see, Magetta?
Hmm.
Um,
We need to call unify.
size position. This the fact that this is one based is so cursed because I can't just.
Why is that one based, man? It's so silly.
Since always Erlang has been, well, LFA also by extension, of course. They are all one based, man.
Wait, lists are one based as well?
Yes,
Yes,
yes they are.
for some
That
reason.
is so cursed.
Yes, they are. We already got some
When
bugs in some of our programs because of that.
size is size is less than or equal to position. Actually, it's the other way around.
Wait, but this is gonna be used for the fold, right? When we recur.
Yeah.
Okay.
Position must be less than or equal to size, and it cannot be strictly less because one based. That's very
Are you sure
sad.
that's the operator, the comparison? Isn't Erlang the one that swaps the less
It
than
is
and
actually.
okay. Um,
Uh, the
yeah,
position is
we need to call
less.
unify now.
Then we need to do. Yeah. case unify env um, element position left element position right.
Off, case off. So either we're gonna have an OK or an error. If you have an OK, we just no, we proceed.
Actually, if
We
we
need
have an
to, yeah, we need
OK,
to call ourselves incrementing position.
unify tuple, same environment, same size, position plus one,
Left and right.
left and right.
And if you have an error, we just propagate the error, I guess. Yeah, that's pretty much it. Okay, now the question, how do you do maps, right? That's the final question for today, probably. How do you do maps?
We actually need a default case here.
Oh yeah, because of the guard, right? Which is gonna be error, I believe. Don't care.
No, it should be okay, actually.
Oh, it means that we are done. Sorry, my bad. This is just an okay, you're right.
Yeah, this needs a semicolon. 1, 2, 3, 6. And this is way entirely too many arguments, but I'll take it.
No, it's not 6, it's supposed to be 5.
Aim size, position left, ear right. It's only 5. Okay.
Oh, maps are much easier though.
Well,
Just map.
Marinho said that it was the opposite. It was harder
Really?
than tuples.
Why?
Uh,
You
I
should
guess
just unify each key. Oh, sorry, each member. You can't have well, things that are non-unified on the keys. Can you?
we can
If the
also use
size
the
is
trick for
0,
lists. So if the
the
size is
position will be
0,
1. Yeah, actually we don't need this. We can just call this thing directly.
why? Wait, why don't we have to check for the case of being 0, the size of the tuple?
Because of this guard here.
Ah, because if the size is 0, we go to the other side there. Yeah, very nice trick, very nice trick.
You pick
Uh,
the size anywhere though.
Hmm?
yeah, you don't have the size, that's true. Just grab the size of one of the things down there.
That is true.
Yeah, tuple size of A or whatever. Okay, so to do maps, can't we just, well, we have an option of using the same trick that we wanted to do for tuples, which is to transform them to a list of pairs.
But wait,
We're
why?
going to
Marinho.
No,
You
we're
can't.
gonna need a list. We're gonna need a list of keys actually. I think there's a way to iterate over the keys of a map efficiently.
We can
So
extract
my,
the
my
keys of a
question.
map.
So before, do we need to compare the? So you need to compare if the maps are the same, and Erlang can do that already. So shouldn't you just unify the values of each key?
We should unify the values of each key, yes, but that means we need to iterate over the keys. And we need to
Yes,
check
there
if
is
the
already
key
a iter
is in
on the
both
map.
maps. Yeah.
Well, but the map function
If you
is key
do
and
if you
value,
do a
by the way.
map equals another, what does it do?
Well, but that
Um,
that won't work for our purposes because there may be references that after dereferenced a bunch of
No, no.
times,
That are after dereferenced a couple of times.
if
then they
there's
will be
a
the same.
yeah, if
Go ahead.
there's a reference in a value of the map, if we just do equality, that's not gonna work
No, no, no,
correctly.
no. You didn't follow what I'm saying. I'm saying map with the unify, and then just check for equality on the map. Doesn't that work?
Ah, so you're asking to us to map the unification on each of them, and after checking their equality.
Yes.
Yeah, that sounds reasonable to me, Marin.
Mapping unification on each of them.
Yeah, so like you map unify on map A, then you map you like when I say map the verb, I mean the F map, okay? So you map the unify on map B, and you grab those two things.
Okay, if I just map unify on map A,
Ah,
what
but
am I
you
unifying with?
yeah, unify doesn't return the structure, Mageta. It returns an OK.
No, even
There's
if it
no okay.
returned the structure, what am I unifying with?
Well, sorry. Dereference.
Ah,
That's what I meant. I meant dereferencing the things on the map in depth.
Yeah, he meant dereferencing. That's true. Yeah, but that doesn't solve the other problem. We need to use maps dot column map. I think my
Yes, maps map.
maps map.
But can you check if you can do equality in levels with maps in Erlang? I suppose you can, like pattern matching, right? Probably
No,
do
you
that.
can actually. The problem is we need to handle references, which are how we represent variables as a special case.
Yeah, we can't just blindly compare them. And here's the thing: we cannot just. Uh, I see what Magenta is talking about, Marinho. He was talking
If
about iterating upon the map, the first map's values, and calling the dereference operation on each one of them until we cannot
yes,
reduce
if
any further. That will
yes,
give
if
us a
we're
map.
expanding depth, that's my point.
Exactly. Then you're gonna have a map that have all the dereference done. You do the same with the second map, and then you compare them. That's what he means.
Now, if you want to not dereference everything, you could do in parts, but I'm not sure if it's even proper for you to just check parts of the map and already discard the unification. Maybe it is, because then you can do like a fold with both of them. You should check for the same size of the keys.
We already
Then
know
you
that.
go,
We're checking
yeah,
the size, but not the keys. We need to check the keys.
yeah, you well, if you can compare the maps after you dereference, that is not needed, right? But if you want to check just key by key, um,
Oh no, I'm not going to allow variables as keys. That's nonsense.
yes, that's my point. If you ignore the keys, like they're just atoms or strings, whatever, then I
Hmm.
think it's fine.
Yeah, he's talking about doing the dereference on the values of the maps in the maps.
Although Erlang supports all sorts of things on the key as well.
Well, they know how to
Uh,
compare all the terms, so I guess that makes sense. Okay, so what's your idea, Marinho? Share with us.
okay, we need to iterate over the keys of one of the maps. Um, and then we basically need to fold by doing a lookup on the other map. Actually, is there a
There,
fold?
there is a fold and there is a values function as well, and there is a fold function.
Yeah, I think fold is perfect. Okay, so fold takes a function, and the function takes a key and a value and the accumulator, right?
Yeah. We need to check the keys to
Let's
see if
make
the
a.
same keys are present in both maps.
Yes, we do, in fact.
Okay. Okay.
Env A B. Okay, so inside of
I
unifier map, we know that the two maps have the same size, and we know that they are indeed maps. So
I
here's what we
still
do.
Magenta?
don't know why you would check the keys though.
Because we need to make
What
sure that the
are you
keys only
thinking?
one map are the same keys present on the second map.
Yes, but doesn't the equality already solve that?
The quality is on the size.
What?
Yeah, look at line
If I
85.
985. No, wait. Equality is a thing, but if I'm doing things like, for example, I have one map with A, B, and C keys,
And the values are different.
whatever content. The values may be different or equal, doesn't matter. Uh,
But the keys are the same.
if
You
I
think equality already checks for that?
yes,
We should test that, Marinho. That saves work. Go to the repo and try to create two maps.
It's
They have the same
yeah,
keys, but the values are different.
that's gonna fail.
Let's see.
what
If
fonts
we
are
have
you
a
using,
map,
by the way?
sorry,
What fonts are you using? I see there's a
Yosevka,
Yosevka.
Yosef.
Yosevka. I really like that font.
B.
Yeah, this is gonna return false.
Yes, that is correct.
Wait, but I thought you were saying that if the keys were the same, the quality would help us.
No, I mean it does if the two maps are the same. You want to unify them, no?
The problem is that if we do make ref and make ref, this will always fail, right? It's always going to be return false. But if those refs are variables, free variables, we should bind them together, and this should succeed actually.
Yeah.
That's why I said about re-referencing depth first and then looking at the equality only, right? Because then if you have them dereferenced, the equality should work, no?
Yeah, but we're gonna end up doing that
That
at the end of the day.
means we will never be able to do this some value. This should work and it should bind the reference to some value. But if we just check for equality, this is gonna return false.
No, yeah, that's also true.
No, but what? Man, and I expressing myself correctly. I feel like I keep saying the same thing over and over.
I'm not getting. Could you repeat?
So what I said is, you have map
Mm-hmm.
A and B. You need to compare
Yes.
them.
Yes.
So there are two things you need to compare: the keys and the values, right?
Yes.
So
Yes.
you need to see if the value of the ref is the same as the sum value. So the make ref, the ref that is there, needs to be also some value for that to be equal. Correct?
Actually, no, because if this make ref represents an unbound variable,
Yeah.
It needs to bind the
It
variable
needs to
with the
bind.
sum value.
Exactly.
yeah,
It needs to bind. It's great so far. Well, what else, Magetta?
maps fold.
So the only problem is that if you're doing depth, you're just dereferencing, you're not binding. That's the only
Yeah.
gotcha, I think.
Yeah, and there is also the problem of what if you're trying to bind something already bound? You also need to take care of that.
I still don't think you need to check the keys though.
No, you need to check the keys because down
All
there.
right, okay, because then if the values are different, right? Makes
No, no, no.
sense.
It's because if we have a key A in one map.
Yeah, the same key but with a different value that you need to
Yeah,
bind to
checking
to
the keys is
generate
because
the
they
thing it will
they
fail.
they may not have even the same keys. That's what we're checking first.
No, that is not really the problem, right? The problem is that if you have the same key but a different value, that it would should work because you need to bind the ref with unbound
Yes.
variable
Yes.
with the some value, then that would fail when it shouldn't, right?
Yes. That's true. ACC.
Uh, okay, and map. Then in this case, and I'm going to use, this needs to be, I can do this, right? Unify, actually,
The
actually
perfect.
no. I need to do key value
Yeah, it's gonna be look ugly as
accumulator,
fuck, but yes, that's how you do that.
unify
Yeah,
kv.
does the fold take three arguments on the
Yes.
front? Are you sure?
Yes.
It
Yes.
does. For
For
maps,
maps,
it
yes.
does.
For maps.
Huh? Strange. I thought it would be a tuple on the first argument.
Okay, so the first thing we do is a lookup on the map.
Yes, indeed. If we, if we're still okay, and we have a
Key
key
value. No, no, that's not how you do that. It's
other value,
yeah, but it's not arrow there. It's column equals.
right? It's actually, yeah, no, that's right. This is the order, right?
Yeah. Yeah, it is that. This is the order. That's correct.
Uh, okay, if we have the key and we have the other value, then in that case we need to do.
We need to
Oh, we need the
dereference.
environment
Yeah, we need the environment. I was
actually.
about to say. We need a way to talk to the guy that derefs.
This is not great, but okay.
Too many arguments.
Uh,
Too many arguments.
okay, so we need to do unify env value other value.
Wait, unify? Don't we need to call env to deref the things?
Unify is gonna do that.
That is
Remember.
true. Yes, no, I agree. That's true. Okay, so we already dereferenced the value and the other value. So what do we do?
If we
If
get
it's
an
not
okay, if we get an okay, we key value accumulator. If you get an okay, we return okay actually.
yeah, okay.
And if we get an error, we return the error. So actually we can just tail call unify in this case.
Yeah, but we need more versions of this function.
We do.
So in the case that the accumulator is not not an okay, we just return that. We don't just like put underscores everywhere else.
Yeah, this is unification failed.
No, but we're still missing the pattern matching if the accumulator is not okay.
Yes, we are.
Everything is underscore essentially. Well, above is also underscore. Yeah.
Oops. Yeah, this needs to be underscore. This needs to be underscore, and this needs to be underscore. So if we are okay, but actually we didn't hit this, which means the key is not in the other map, we error out.
Yes. And if we have underscores everywhere and it's not an okay, it's whatever error, we just propagate the error.
Let's see.
Wait, I think we should just propagate the error, no? Yeah. Dot. Um,
Yeah, I think these are better like this.
yeah, okay, that actually makes a ton of sense. So you're folding the first map, doing lookups on the second map. If we found the same key on the second map as the first, we unify their values, which you're going to be doing the reference and so on. If your accumulator is already okay, but we didn't find the key of the first map on the second, we say unification failed. And if we have an error already, we just propagate the error. Does this compile? Can we check? Well, not compile. Is the REPL fine with it? No.
Variable key is unbound.
Oh, you can't use it on the same level of the definition. That's silly.
Wait, what?
That is kind of sad actually.
Wait, what?
Yeah,
What was the
it's
problem there?
you can't use the variable you are binding on the function with the same. Yeah, you need to do that.
That's.
I don't think you can
Is
do the when, but try.
But that worked in LFA. That's kind of
Well, I don't know
weird.
what LFA does.
That worked in LFA, right, Marinho? We used this property last week.
actually that's not what I wanted.
I
And
know because
also,
the ETH has the same had the same issue.
Very tragic that LFA can do it, but Erlang can't. Disappointed. I'm very disappointed. But well, most languages don't allow you to do that anyway.
yeah, we actually can't use. We can use map get apparently, but not iskey.
Why can't you use this key? What's the problem?
Functions allowed in all types of match specification. Do we have iskey here? We don't.
Okay, so they don't allow any predicate to be there. That's kind of sad. Okay, let's use the map get then.
Hmm. Map get
Key map.
takes a key and a map.
We're also gonna have this problem in other places as well because we were kind of assuming that it would do the unification for us. I'm starting to be doubtful that we managed to make this work in LFA. Maybe I'm dreaming, but I remember we used it in the pattern matching.
That does sound like wishful thinking, yes.
Wait,
Don't
can't you
expect
just
much.
rename the? Ah, this is not OCaml. Ah, fuck it. Okay.
No, because this is actually maybe we
Oh,
can.
pruning. Pruning, you can.
Oh, you can. Okay. How do you do that?
I think that's just
Because
S.
yeah, because this is not actually a Boolean function, is it?
Oh, we gotta read the docs.
Yeah, this is a guard function.
Yeah, but what does map get return? That's kind of the. Yeah, it returns the value. I'm reading the docs. It returns the value.
Match variable, match conditions is a sequence of match conditions. Can be a guard function or a guard function followed by a conditional expression, which can be a match variable or a term construct.
But isn't what Mageta said just putting s in the guard to use the name of it?
I don't see as on the syntax tree though. Maybe it's equal.
Wait, a conditional expression
Match head, match variable.
can be after a guard function. A guard function, yeah, it has to be one of those. Oh wait, these are not. Yeah, no, these are not. Guard function. It can be followed by a conditional expression, which can be. Okay, let's try to do this in the REPL actually. That's probably easier to check. So if I do Karuta, map is unused on line 62, which is blatantly not true actually.
Wait, variable map is unused on 62. There's no way that's right. There's no fucking way that's right. Did that change anything? Yeah, that's syntax error.
Before the map gets apparently.
Yeah, no, that was not correct, for sure. But now I'm wondering if you're getting bamboozled. Yeah, it's a function,
Mm,
man. It's not an operator. It's a function.
but that doesn't work either.
No, no, no. But maybe it's because of the equal. Maybe the equal is confusing the parser.
But that's not what it's complaining about. It's saying that map is unused.
But let's just try it. Remove the equals to other value, and let's see if it keeps complaining about the same thing. It will complain about the other value right there. No, no. Sure. Yeah, it does change things. See?
Okay.
Yeah,
This
but
is kind of
maybe.
sad, but
Yeah,
okay.
but you can't do equals on a guard to have the thing. I wanna die. Guard Zerlang.
And before in Haskell, you're feasting in OCaml, you're feasting as a king, Lemus,
Yeah,
and
no.
complaining.
Well, we were living very great there. Well, now we can't do. Very sad, man. Very sad. And you know what's the most saddest thing ever? Is that we're doing Erlang, we're not using the maybe monad that they added. That's what I'm sad about.
All right, that's a thing now, right? I forgot about it.
Yeah, but according to the examples, it needs to be a tuple. We are using the atom only, so I don't know if that works. Because
What's
back
the
in the
name of
day,
that again?
just put maybe in there. It should pop up.
It probably won't actually.
Okay, let me find the thing.
Expressions, maybe. Okay.
Maybe feature introduced in OTP 25.
Yeah, so we were back in Lyceum days. Like, if we had this, come on,
Yeah,
man.
this should work actually.
Wait, I didn't understand. What does that do? So
It's
you
the
have
meme bonnet.
cases.
No, no, no.
Oh.
When you
Oh, I
do,
see. Those are not cases. I see. Those are
yeah,
just it's just code, right? I see.
yeah. So if you do the question mark equals, if it returns an OK, and there's even pattern matching. Can you scroll down? Uh,
So it needs to return a tuple with OK in the first guy. And what about the error?
yeah, scroll down a little bit more, more. See that you put the pattern matching there. I think for the errors.
Hmm. Error expression and then else and then patterns.
So if any of them fail, I think we can put a pattern match to like deal with it if it fails. Yeah, look at that. Look at the example there.
Yeah. Yeah,
But
no, this should work
yeah,
actually.
but the question is, does it need to be a tuple with
No,
OK?
it doesn't. It doesn't.
Oh. Okay, so we could, for example, this case, we could use the maybe expression here.
Hmm.
Because man, if we had this, if we knew this back in Lyceum days, fuck me, man. That would be a god saviors.
Uh,
The only sad part is that this makes like most of Orlando and Orlando kind of useless because this accomplishes half of what it does via the macros. But in there, you can at least define your own monads. This one is a fixed monad, so
what do you mean fixed?
fixed. This is only works with OKs, right?
No, this works with any unification actually.
How does he know?
Well, it does the pattern
What are the
matching.
unifications that are valid?
Well, it does the pattern matching as usual, and instead of just throwing the exception, it goes to the
Oh, I
pattern
see. So it
matches of
just
the else.
captures the exception. Hmm. Let me try an
Uh,
example here.
well, but it still can't do a custom monad, such as a Postgres monad that we did.
Oh,
You need
that
more
is
power to do
probably too hopeful.
that. Yeah. Go on, Maria.
Yeah, no, we can do something like this, I think. Maybe and not here. Then we do OK question mark equals this.
And then the result is gonna be the unify of the TATB. Look how much prettier that looks, man.
Eh, I I see. So I need to use that funny syntax.
Yeah, the question mark equals.
Uh-huh.
Yeah, this reminds me a lot of F sharp computation expressions.
Well, 10 times worse, but yes.
I don't know if I agree with the 10. Maybe one and a
You can
half.
extend into whatever you want, man. I don't think you can do that here.
no, it's unification. So like this is not exclusive to OK. If any unification errors that you have, it will throw an
Yeah, but
error.
my point is that is not an applicative either, is it?
No, it's
I don't
not.
think so.
No, it's purely the let
Yeah,
bank.
exactly.
Yeah.
Yeah, it is just binding, right?
Yeah, this is just a bind. Yeah, I agree. It's not as powerful as like being able to do applicative and stuff. But I like this idea because we suffered from this in Lyceum. That's why
I
we
wonder
looked
how
for Erlang.
lenses. You know what? I wonder how lenses will look in in Erlang
I have no idea.
because they're very useless. In well, I would not say useless, but I can hardly see the point of them existing like F sharp. Um, I don't think you gain much with their syntax, right? But in Erlang, I think you can fix a lot of the syntax
Well,
problems with
lenses is
it.
an approach for statically typed nested data structures.
Well, they can be dynamically typed as well, except then you can bypass a lot of machinery because, like, for instance, um, like you have a Soci, for instance, in Clojure, and that does something kind of similar to what you would want to do with lenses, right?
Hmm.
The main thing about lenses, though, is that they are composable, and a Soci is like it takes a vector of keys.
Hmm.
Yeah. Yeah. Anyway, so let's finish that function there to keep make this compile. Um, okay, so syntax error. So now I'm not sure. That's how you use the maybe. Let
Hmm,
me see the example again.
Maybe not.
Maybe not.
maybe not.
Funny, funny. Uh, yeah, it's
Oh,
form.
which version of Erlang are we running?
I think 25.
Check
Oh, you need
version.
to go. You need to go to 27 to be default, right? Yeah. So 25, we need to do something to enable it. Or we go to OTP 27. Do we have OTP 27 in Nix? Let me check.
Uh, we do. That's what I'm using.
Well, but we added to the flake. Oh, we need to do a Nix flake update maybe.
We're also taking a legacy package. Is that a problem?
No, this legacy package is another thing. Just put underscore 28, Marinho.
Oh yeah,
There.
there is a 28 specifically for 28 version. But then you need to get out of the Nix develop and yeah, it fucked itself. Yeah, Nix flake update. Let's try that first.
Wait. Which branch are we using? Which input, right? Check the inputs up there on the flake. Flake utils. You're just picking whatever is on the OS, I assume.
Yeah, no, we need to do a
Uh,
Nix flake
well,
update.
just do flake utils then. Yeah.
Nix flake update. Let's try to upgrade the shit out of this. Oh, there is an Erlang
Oh, there's
27.
27. There's 27. We don't need
But
28.
we should, yeah, but we should update it at some point. But okay, let's try. Because if Maget is using 28, we should use the same version to not like to how should I say to get lower the chances of having incompatibility problem.
Setting yourselves on fire. That's always that's always good.
That's always good. Yeah, the syntax
Error.
is
Yeah,
now proper.
there we go. Uh,
Syntax error on line
syntax
10,
before. Oh, I forgot this.
semicolon. The next one, yeah, error before the dot on 46. 46 is way down there.
Mm,
Too much. What's wrong? Receive V, return V. What's the problem?
oh, I forgot this.
Oh, an end.
Um,
We need to maybe put the environment behavior. Wait.
That's probably a typo, no?
Yeah.
Environment behavior.
No, it's correct.
That is correct.
I'm confused. It's saying environment behavior is undefined. Do you have that up there?
Yeah, it's the same string in all three places.
Okay, so function dref is undefined. That also is. Oh, let's actually recompile the. Retry again. Maybe because it couldn't parse them. Syntax error before line 13.
Probably
Probably
missing
semicolon again.
semicolon here.
Try again. Okay.
Yeah, that was very weird.
Okay, but
The
we
next part.
finished. That is it. No, at least for logical variables, right? I'm not talking about backtracking.
Yeah, now for backtracking, we're probably going to need to change the state here to be a list, and then we need to add save and well, save and pop, I guess,
Yeah, no, but
or duplicate and pop,
in
I
terms
guess.
of logical variables, what are we missing? That's my question.
And in terms of logic variables, that's it actually. We can, um, yeah, we can unify, right? And this dereferences the A and the B, and we can deref variables.
What is the name of the function? Oh, it's because it's a fresh variable. Okay. Okay. Can you do me a favor? Get out of the REPL and try to compile this file to the symbolic representation. I want to look at it. Earl
Okay,
C
Earl C
dash
dash,
S.
that's lowercase, right?
No, capital. Yeah. Karuta Earl. Okay.
It's this one, right?
Damn.
Yeah, 500 lines. Yeah, there's a bunch of stuff here.
Yeah, but this is very good because we can write Erlang and understand, like, and quickly see how it translates because you're gonna have to basically eat these and get familiar with it to understand it properly.
Well, you can always just put this in an AI, right? And expect it to give you the correct output.
Of course. I'm gonna finish the
You're laughing,
recording
but
now.
that's the industry